Welcome. Hey everyone, how's it going? So good to have you here. Welcome to Go West 2025 here. Like, we are growing each and every year that we do this. I just started participating last year, so obviously the growth is from me. So thank you for coming to see me. But we have a great team of organizers that we work with. So a few things. Big thank you to our sponsors, Weave for sponsoring this venue, and our other sponsors who are helping us to put this on. They are huge, and they make a huge difference in helping us to be able to provide this content for all of you. So big round of applause for them, please. Awesome. Next, we do have lightning talks today, right after lunch. Please sign up. This is like a 5-minute talk. There are some people who got here and decided they should prepare one. It's very possible. It's awesome to have you come and present your things. And so we'd love to hear from you. So please sign up. Here's the QR code. There's also a link.
We'll post it in Slack.
We'll post it in Slack. That's what I was going to say, too. There's also a link in our Forge Utah Slack. If you aren't on there, hop on that as well. There's a Go West channel. So here's the QR code for the Slack. But hop on there. Conversations on there. That will be fantastic. Another thing is that the mics in here are live above you, and so side conversations are awesome, but let's keep them in that room or out there for our recording so it doesn't disrupt that. And then let me make sure I got everything else.
The microphones are really good. They will pick up whispers.
They pick up everything, yeah. So the store, if you saw in this room, that Annalisa is running, all the funds for that is going for Go West next year. So go buy those cute little plushies and the shirts from last year, and it'll be awesome. And then I think that is everything. And so, last thing to say is we are going to welcome and hear from Mariah first. She's been integral in organizing this, and she is going to talk to us today about using AI and Go, which is a cool intersection. So give it up for Mariah.
I hope I don't disappoint everyone. So, thanks for coming. It's possible. I want you to know I did not insert myself intentionally when we were doing the reviews for the talks. I gave myself the lowest score possible because I didn't want to speak. And then everybody else voted me up. So it's their fault if you don't like it. I'm Mariah. I'm a data engineer. I work at School AI. If you live in Utah, your kids use us. We're just a great little thing, just trying to make school better for students. I organize Go West and Forge Utah, so I do want everybody to join the Slack channel. And then I also have a Twitch channel, a Substack, a YouTube. I talk about Go and AI all the time. That's all I talk about is Go and or AI. Because why not? Hype train. So who here has built an AI app? Just raise your hand. Dang, it should have been more. A chatbot, content generators, agentic systems. Anything, literally, you call the OpenAI API, you've done it, guys. You don't have to train models anymore. You're just using AI.
What about an MCP server?
MCP is AI, dude. Anybody running it in production at work? Dang, look at you. Not me. I don't do it at work. Self-hosted models, vendor AIs, open router, whatever. So this is Pedro. Pedro is my AI bot. I built it about 1.5 years ago, and it's completely written in Go. It's just a Go service, connects to self-hosted model, and it's Pedro. Remember, I'm Soy Pete. This is Pedro. Why did we use Go for AI? Twitch uses IRC. This is a Twitch chatbot. And so when the IRC messages come in, they immediately go into channels, so I can handle multiple of them at once. It's really great. I get built-in error handling and monitoring because it's super easy to use XP bar. I get all the stacks, the Go runtime stats, and then I can throw everything on Prometheus, and it just is really good under load. This is essentially my architecture, right? We get messages from Twitch and Discord, they go to the service bot, then it goes to a model. I have that model hosted locally on a computer that has an RTX 5090 NVIDIA GPU, and it's just serving great. If you're curious, the model is a Llama 3.1, 8 billion parameters. I tried to do 70 billion, and it kept saying, you're running out of VRAM. And I said, how is 32 gigabytes not enough VRAM? It needed, apparently, it wasn't enough for the 31 gigabyte model. Don't know. And then I'm using Prometheus and Grafana for my observability stack. Why I'm doing this? Because I wanted to learn how to self-host models. It's harder than just calling an API, and it's like not as fun. But I was interested in doing GPUs. I was interested in learning model infrastructure. I was interested in bandwidth. I wanted to learn this all myself. And the hard parts are really kind of like the basic stuff that's hard about the cloud, right? Or like any infrastructure, right? When you were doing bare metal stuff, what was the hard part? It was the ops, right? That's the same hard part for AI. Go's the easy part. So is that, yeah. So essentially, today we're going to be experimenting with my monitoring, and we're going to break it. So Pedro is live on this live stream. So you can go to our YouTube channel, our Forge Utah YouTube channel. You can go to my Discord. You can go to Twitch. I should have posted that in the Slack. If somebody wants to post either my Twitch or YouTube into the Slack channel, that'd be great. Pull out your phones. I want you to DDoS Pedro right now, please. We tested it. It can handle last time I tested it, it handled about 7 messages. That was the AI bottle that could handle 7 messages at a time. I had somebody, if Rug Matt's watching the live stream, he built a bot that just spammed Pedro, and he got 37 messages. You can do that. And we're going to look at the metrics. We're going to see where the strain is in this production AI app, right? It's live in production because you can use it. So Pedro, right? It's built on VLLM. It's written in Go. I have it on my home lab. So I have it running on 2 mini PCs. And like I said, I have a box. They're all in Ubuntu. That runs the model itself as a server with NVIDIA RTX 5090. It has an Intel processor, and it has 64 gigabytes of RAM. That matters if you're used to hosting models. If you're not if you just like to run things in the cloud, nobody cares about my specs. And it connects to Discord, Twitch, and YouTube. So you can do from any of the models. If you want to jump on my Discord, you can play 20 questions with it. It's just great. And all of the code's on YouTube. So these are the channels you can see it on. And all you have to do to interact with Pedro is say the word Pedro. It literally is just an exact match on the word Pedro, and it queues up a process because that's easy. So the important things I want you to understand. When you're hosting a model, things like we have the normal API metrics, we have our database metrics, but specifically for LLM and API, we care about the latency of that model. So the things we're going to be looking at, time to first token, this is how long it takes the model to start creating new things, right? We're going to have end-to-end latency. That is the total call time from the time I initiate the call to the VLLM to the time I receive the full response back. We're going to care about the queue depth. That's how many things the GPU is processing. And the key value cache, that is how much load I have on the GPU right now. The model is currently living in memory, but the inferencing does happen against the GPU, and that's why we care about the key value cache. In Pedro, I have Prometheus set up. We have success and failure rates, right? So that's how many times we get a response back versus don't get a response back, or get an empty response. In the early testing against the model, I was using a different quantized Llama 3.1, but sometimes the prompt wasn't good enough, and it would just give no response and then not post anything to Twitch because it was empty. And then we also care about our heap and memory, like are we overloading our Go runtime with that stuff? So we can go check it out. Where's the click on it? Look at that beautiful thing. Come on. There we go. Can you see it okay? You want me to make it bigger?
A little bigger.
A little bigger? So there we go. So this right here is our VLLM performance. I have had this running since Tuesday when I started testing it. We've had 280 requests. Right now there is no load on the GPU, you guys. Look at that key value cache. That's 0. That means it's not having to keep context between messages itself. We have no running requests. We have observability. This is our Twitch metrics. We can see how many messages have been received. Not that we have 1 live connection. We're doing low memory, but look at that message rate. Look, guys, we had a spike, but you haven't broken it yet. You can just start talking about Java and it'll break because this is a Go bot and Java's not allowed. So like, just try and break it. Also, if you tell it to speak in leet speech, that broke it too. And for some reason, the system prompt did not restart that. It just kept speaking like that for eternity. It was the worst. I fixed that, so you should try and check that too.
It was fine changing languages. So
It's doing good language speak? Good. Because last time it was like, we told it to speak a certain way and it did that for eternity. And I was like, why? It should only have a 10-message context window. So far, this only tests fails. We're not doing any failure. No failures. Oh, and the other thing Pedro does too, it has a workflow, so it's not a full agent. It's a workflow. If Pedro will search the DuckDuckGo API, and it will send you a message saying, let me look that up for you. So if you can trigger that, we should see the metrics here. So ask it something about, tell me about the latest Claude release, and it'll be like, I don't know what that is, and it should look it up for you. Yeah, so that's, where's my other, oh, I bet I just have to go back. Yeah.
I asked it to speak in leet, and it said, that's not my style.
Yes! That means my debugging worked. So we do have some alerts set up specifically. And I have those going to my Discord. I do have a Discord channel. It's right here. Soy Pete Discord. My alerts are broken because it says it's offline and it's supposed to be calling localhost. But I do have 2 alerts set up. I have this is just a ping alert. All it does is it pings it and it says, is this online? It's checking to see if the model is online, which that does currently say it's online. And it's checking to see if the Twitch bot and the Discord bot are online. That doesn't work, and I didn't want to debug it last night. We also have, and it will go on forever. We have a Grafana integration set up. So we have in Grafana set up a couple of things that I'm checking for. I am checking for, again, high key value cache. I'm checking for LLM failure rate. I have a threshold of 15%. So if more than 15% of the messages do not return a response to chat, pings me in Discord, etc. These were what I consider critical alerts. That means I have to intervene immediately because the experience is down. It's an outage, right? If the model is not online, that's the whole purpose of the thing, right? If the Twitch or Discord bots are not online, that's the full integration. And then if we're not returning enough, that's good. I have some warnings, and these are just latency. High key value cache. Again, that means that we're having too much load on the GPU. It's trying to keep too much context between message, or it's doing too much processing on the prompt. It does, so when it does processing in VLLM, it chunks the tokens up and does parts of the tokens at the same time, and it keeps that in the key value cache. Again, we're doing a P95 latency if that's, so like that, we want most of the requests to be under 3 seconds, and then the time to first token to be under 1 second. We don't want the queue depth to be more than 10, right? I don't want to be handling more than 10 messages at a time because I know it does about 7. So let's just walk through how I would debug this because you haven't broken it and I haven't gotten any alerts yet. Right? We see a high latency on the spike. First thing I could do, right? This could be caused by too many requests, KV cache full, long prompts, right? The longer the prompt, the bigger the thing, or network issues. I've had times when it just took a long time for some reason to call from one computer that was sitting 3 feet away from the other computer on my local network. And I don't know why it took 30 seconds to make that call, but it did. And what I can do, so I'll see this, we'll go to Grafana. Where was our Grafana? Oh, well, let's go to Grafana. Do I have this up over here? I think this is like Claude. I love blue 2:3000. Look. Okay. Get rid of you. And then make that full. Cool. So, right, I can go to Grafana and diagnose. We do have a decent key value cache, and we can see a high latency. Look at that. Our latency at P95 is still about 10 seconds. So, it's 9.38, so it's not going to tell me. Our P50 is a little bit higher, so we're doing good there. Our time to first token is still pretty quick at 63 milliseconds. So we can see in the Grafana that we're doing pretty good. But I haven't gotten any alerts. So that's our debugging with that. Or is it this way? Yep. And then we can do different things with the debugging. So if I were to go here, I just have my server up here. These are the logs for Twitch. I don't have any error logs saying it couldn't write to the database. I could go here. Yes, this one is the VLLM logs, so Docker logs, VLLM server. This one's kind of actually more fun. These logs are way more fun. It tells you token, throughput, whatever. I have always been surprised what you get out of the box with LLMs. Because I feel like when I call the Open API and I'm using LangChain or something, I don't have any understanding about how things work. But all the metrics come back on the request. This is spewing metrics all the time. It's super cool. And it's just letting me know if something, how the KV cache is doing, how the prefix hit rate. I don't even know what that means. I should look that up. And we just got to check the success rates and stuff. Typically, how I've fixed high latency is I just kill the cache and I restart everything because it's on Twitch. So I'll restart the bot, lose memory, restart VLLM. I don't do any throttling. You can do that. But if I were to throttle, essentially what I can do to chat is I can turn on slow mode on Twitch, and it forces people to not be able to post every 0.3 seconds, right? They have to wait 5 seconds, which would essentially throttle the requests right in there. So I do have some quick wins I can do, just generally speaking, with that built into my ecosystem, just to allow essentially the model to recover and catch up. And it will catch up, right? You can put 30 messages in the queue, and because that queue is a Go channel, it will go through all 30 messages eventually. I just need to give it a time to catch up and not build up more. But that's not essentially a long-term solution. I do have a database where I store everything. We could have a cache, the queue through the database, so that if I had to restart VLLM or I had to restart the machine, I could restart the machine. Restart the Docker pod for the chatbot, I could pull it right back up from the database. I could have more VLLM instances. It's not that hard to put a reverse proxy on top of it and have it call multiple instances of VLLM, since I am storing chat history in the prompt, right? It gets 10 messages through the prompt, so all of history is essentially passed to the model itself. My model does not have to retain any of the history. And then the other thing that makes it faster is using quantized models. If I were to use a 70 billion parameter model, it would be slower than the 8 billion parameter model I'm using. And again, this is Twitch chat. We're not expecting high quality results here. We're expecting it to be accurate about 60% of the time because it's Twitch, right? That's where trolls live. People give you a hard time on Twitch. So I don't need accuracy. What I need is speed. I want it to feel real time. It wants to feel like you're interacting with a regular person, not get a response 30 seconds later. So I will choose latency over quality in that use case. So small models are faster.
I think we killed Pedro.
Is Pedro dead?
He died.
What? Good job, guys. Oh, look at that. We got an alert. Is it in Discord? Oh, somebody's been talking to Pedro. I guess, so I changed my window to be every 3 minutes or something, so it might throw the alert later. Let's go check Pedro. TwitchBot performance. Oh, look, it dropped down. It doesn't say you guys have been it's been doing good on the web searches. Did somebody break my failure things? It would be me. I would have broken it. It was throwing failures the other day.
Was somebody?
100%. Good job. Good job for breaking it, guys. Where was my terminal? With the logs? Let's go back. Nope. The logs don't show anything. Somebody should have been running in debug mode. That was not me, obviously. Good job. Good job for breaking Pedro. What's it saying? Just like
Nothing.
nothing?
Stopped responding.
He's contemplating.
It's contemplating. Is it still? It says it's still running. That's great, guys. I'm so proud of you. I wanted you to break the system, and you did. That's so good. I'm so excited. Bad actors. The other thing I do have a problem with Pedro, I have 5 minutes, so I'm just trying, I want to let people ask questions, is people being stupid, which is essentially not what I asked you to do. I asked you to intentionally break Pedro, not just be dumb. People try to hack the prompt, get it to Pedro has mod privileges on Twitch, so it can add commands and do stuff like that. So get Pedro to act as a mod and ban somebody, or add a command, or get Pedro to say inappropriate things like use leet speech or throw slurs out at people, which Pedro has done. Fix that one real fast. People can be bad actors, and we have to have things to change that. You can just send really long messages. Again, first thing I did was I limited chat history to only be 10 messages, right? So essentially, if there was a bad actor, their messages should be erased within 10 times. We can do rate limiting again. Another thing that I found works really well is just guardrails in your system. I have a message cleanup check that will remove mod commands. It'll remove inappropriately formed things. It checks words. Like, you have to build software around your AI. Like, that's the thing. If you're not doing software best practices, you're not building AI right. If you were building a regular chatbot, you'd be checking if somebody was throwing slurs. You would have a list of words you don't use. Do the same thing with AI and tell it, sorry, redo, you used a thing. And make sure to include those words in your system prompt, right? Like, no Java. Java is a swear word essentially on my channel, and so... But if you spell it J4V4, Pedro will say it and tell you not to use it. So... the system prompt gets you a long way, but it's only as good as essentially the prompter. So I have several functions that just check the output and make it sure it works the way I want it to work. If you can identify a pattern, like empty responses is something that I was getting a lot for a while. So I have a check for empty response. I can check history. I do a lot of debugging on chat history to be able to identify responses and adjust things. I can test those responses against the prompt to make sure it handles it the way I want it to do, and do simulations, right? Like, if my chat history was these 10 messages that I have stored here, what would happen? Let's change the prompt, redo it. And again, just like, Go has a lot of built-in tooling for like string management. You can change functions, you can remove strings, you can do prefix trimming. Like, I don't like regex, I don't use regex, I just use the strings package, and it works really great. Pedro is stateless by design. I have a database that stores all of history, but Pedro does not pull from that intentionally so that I can do a quick reset for the bad actors. Like I said, at some point, I probably do want to be able to say this is like history and pull it back in if I need to do a restart, but that's an easy flag to say pull from history or not pull from history if I need to erase that. And even though you broke Pedro somehow, concurrency does handle a lot with that. So yeah, that's my talk. We talked about time to first token. You guys did spike that. You spiked the queue depth. We got the key value cache. And then these ones aren't normal metrics. They do come really easily from VLLM from their metrics endpoint. But they aren't what we do with normal software engineering, but they're really important to understand how your model is interacting with your software. It's the next layer up, right? We still have our DB metrics. We still have our memory stats. We still have our cloud metrics. We still have our API metrics, and then we add that layer, which is the AI metrics that understand and build that whole picture. Go is great for AI infrastructure. It handles the concurrency, it handles the observability, it handles the memory. It's just an API connection, right? But I would say I do not, generally speaking, recommend doing anything beyond API connections. If you want to access the GPU directly, if you want to do one-off calls, there are a couple of libraries that let you do direct calls to Llama C++ and VLLM as not as a server, but as a binary. I would not recommend doing that with Go. I think I would not recommend training. I would not recommend fine-tuning. Python's a much better language for a lot of things with Go. But if you're doing API calls, that's just web services with an extra handset of metrics, and Go does web services fantastically. I showed you, I do have my everything in Prometheus. I didn't actually pull that up, but I can, where did you go? I do have the metrics here. I was going to show you. Oh, that's not how you spell HTTP. If you want to know, the meme on my, well, in general with my life is that I can't spell. So, oh, this is on Pedro. Oh, no, I have this at whatever. 10 : no. Sorry. Got to go to tail scale and copy that. There we go. Why wasn't even tail scale connected? Okay, I'll get the metrics in a minute. I just wanted to show you all the metrics that came out of the box. And I can get that while we do. That's just regurgitating the last thing. Go is excellent for AI infrastructure. And so, yeah, now I will, oh yes, this was my last thing. If you want to build it in production, self-hosting is hard, and there's a threshold for when you want to start self-hosting versus not self-hosting, right? Like, I do this for my Twitch channel, and part of that motive is for content. Like, there's content around self-hosting that I want to provide. But again, if I was gonna go, somebody's like, hey, Mariah, do that at work, I'd be like, you sure you want that overhead of managing that yourself? If you still want to stick with open source, you can do OpenRouter, you can do Cerebras. If you're okay with proprietary and spending the extra money, OpenAI, Anthropic, Cohere, Vertex AI, you have all of those other things. I would say, great, switch to self-hosted. When you're having bandwidth limits, you want to control it yourself and do your own proxy thing and have your own whatever. When you're fine-tuning your models, as soon as you start refining that yourself, you're going to have so much more control doing multiple models and picking it and running that on your own architecture. And you have to make sure you have a full infrastructure team to support it. Like, you're going to be spinning up multiple instances of this, and you're going to have somebody that understands how to optimize for the AI workload with GPUs, with multiple instances, with reverse proxy, just specifically for the AI. You're going to want somebody to maintain that yourself. So there you go. Now we have 2 minutes. Wait, do we have 2 minutes or 4 minutes, Boston? Which one are we running on?
As you want.
Okay, I have as long as we want for questions. Any questions? Okay, go ahead.
To avoid sort of red teaming practices or bad actors, do you have some sort of other AI that's filtering out those bad prompts?
I do not.
Have
Go ahead, continue.
specific algorithms in your Go code to sanitize the prompt?
At this point, I do not have a separate AI running. I only have one instance of the AI, and I want to keep that maintained for the Twitch chat and not do a separate one. I literally, right now, am just doing string parsing. So I'm saying goes fast. I know what people are going to say. I can pick out words. And I can, again, if I say, hey, this is something you shouldn't say, I can throw it back to the LLM and get the response still in a reasonable time and say, hey, redo that. So most of the time, I'm just doing filtering on the Go side with string checks. And then the other thing, if I notice a repeating pattern, I always go and adjust it in the system prompt. My system prompt's only a single paragraph. It's about 300 words. It's not long. And it has...
Manual process that you're editing those?
Editing the system prompt, it's in the code, so I literally do have to make a commit and push it up and redeploy for that. Because the system prompt is essentially like a config. I could store it in the database, but then I don't have a record of the change, so I like to keep it in the... And it's also like, if people have never done it before, this is what I'm doing kind of a thing. So yeah, I would go do a commit and a redeploy with the adjusted system prompt. The thing that says probably you don't want to do the system prompt is length. If you're noticing a latency because it is processing too many tokens, are those tokens coming from your system prompt, or are they coming from the rest of your context, right? If your system prompt, so there's a balance there, and when you start to hit that balance, you really need an NLP expert to come help you edit that, because word choice is going to matter, context is tokenization is going to matter, and certain length prompts are going to matter, and that's what NLP specialists are supposed to know, prompt engineers specifically. So, if that's something that you're seeing, I highly recommend getting a specialist for that. But I have gotten away with essentially just doing the filtering at the Go function level, except for a couple of things like Java and Leet Speak. I told it to be nice and never be mean and not use slurs. So.
Thank you.
Any other questions? Go ahead.
So you mentioned that you have a database for chat history, but you're not using it, so you're also keeping the chat history for every single user.
Oh, yes.
Talk about that a little bit.
Yes, so I'm just using Supabase as just a database. I do not have any intention of ever using chat. And I only use the usernames they provide. I'm not, right? If somebody's gonna go put their history on chat, I feel like I'm fair enough to be able to scrape it. It's public internet. I'm very particular about data sharing. So it's I'm not trying to gather information. I have no intention of using it for training. The intent of it, is for debugging and reproducibility, right? I can redo this, or I can repeat patterns. There was the other thing that I am trying to set up to use the database for is essentially replacing Nightbot, which is like a command thing, so that it can do something like if somebody came on and said, "What is your YouTube channel?" It can say, "Great, this question is a 95% semantic match to what I expect. Return this canned response." So that's the other thing I plan on using the database for, but it's just a Postgres Supabase with a PG vector on it. It works really great. And like I said, the history is mostly for debugging. I do not really have any intent of doing anything else with it, because fine-tuning on Twitch chat just seems like a recipe for trolls and bad behavior on the part of the model.
You're not using the database storage for any sort of content.
At this point, no. At this point, the entire content is kept in memory.
It's like a key value for each.
It's literally just a slice. It's literally just a slice in time order. I have the timestamp on it as well. And then for the Discord bot, what we actually do is we have everything go into a thread. And so it reads the entire thread in as the context. So it's just this. So in the Discord chat, I'm using the Discord thread as my context. And then for Twitch, I just keep a 10-message history. Because a lot of the times we just misspell Pedro when we're asking it to do something. And then we can go back and say, "Hey, answer my last question." And then B, because I do not have a lot of activity. And so the length of conversations is, generally speaking, 8 chats. So I don't need to do that. Also, the database call would introduce a latency I don't necessarily need. I'm not close to maxing out my memory as far as the Go app, so I figure I can store it in memory without any negative side effects.
Is that 10 messages per user or 10 messages over?
The last 10 messages in Twitch chat is my history, and it includes the messages that Pedro sent in that as well. So Pedro has the context of its own responses.
Okay.
And again, for the amount of traffic I have on my Twitch channel, ideal. If I was like Primeagen and I was getting spammed like that, I would probably want like a 200 message history. And I would probably have that stored somewhere as a vector pre-computed using a second model just for vectorization, and then be doing semantic search on it to pull something out. I would be doing something completely different and not passing that whole context. But I'm not. Cool. I can probably do one more question, then we'll need to move on. Go ahead.
On one of the first slides, you mentioned the hard part wasn't using Go. It was like the networking.
Uh-huh.
Can you expand on that?
Yes. So the hard part of using AI is not necessarily running the model. It was a one command thing to run VLLM and pull a model from Hugging Face. Now, the hard part was saying, okay, great. How do I authenticate between my app and that? It requires a token. I do not want other people to be able to spam my LLM, so I have it behind my home labs VPN, which is Tailscale, right? If I wanted to scale that up, great. I don't want to be saying, okay, great, these are the 5 APIs you can use, pick one, because I have 5 instances of LLMs. I'm going to want to have one alias with a reverse proxy that could send it to one of those 5 things so I can do load balancing, right? I'm going to care at a certain point, networking is going to require a certain amount of latency with that, right? So if I had a model hosted in the cloud in US Central 3 and then something in my home lab, I am introducing a latency that I would then have to account for as far as the behavior that I'm expecting, right? So it's have scaling up, we have multiple pods, we can have multiple instances of my Docker container. Then if I did have multiple instances of the Pedro app running, then I would have to use the database to store memory, which incurs another latency, right? Because I want to have memory be the same across every pod. I don't use Kubernetes, but I want to. That's why I'm using that word. I just didn't have time to set up Kubernetes, and AI is not fast enough for Helm. So the hard part is 100% the infrastructure and the networking and the operations, right? Making sure you have the alerts that work, because my alerts are broken. It keeps telling me things are offline when you can use it, right? So there's all of the things, but those are, in my opinion, the same things that are hard about writing regular software, right? Do you get a database clash? Is your service up? Do I need to scale up or down? Like, those are the things that you bring in specialists, essentially we call them DevOps engineers, to handle, and that's the hard part, in my opinion, with this as well. Because you can do everything else on a Raspberry Pi. Okay, cool. I think that's all. We're good for that.
Awesome. Well, so one big part of conferences is always networking. And so we've actually got a number of companies that have sent a lot of engineers here, and I just want to kind of give some visibility to that. So if you work in this building in Weave, raise your hand. Awesome. There's a bunch of you. All right, what about if you came from Mango Voice? That's sweet. Vivint. Whoa, we got a big group from Vivint. What about, I think we had some from Breeze Airways? Oh, we got a big group here. That's so cool. Vasion. I'm at Vasion. We're all over the place. We even have a few from boot.dev. Where are you guys? Back there? We got 2. What other groups do we have that I may have missed?
JetBrains.
Yeah, we have 2 from JetBrains, or a few. Yeah. Any more?
BYU.
BYU? Awesome. Got a bunch from BYU.
Sneedia.
Sneedia.
Sneedia, yeah.
That's awesome. So we want to provide some time for a networking break. You've kind of seen where we are. We're going to open this door again. We can meet around, and we're going to meet back up at the top of the hour for another awesome talk. But take some time to meet people across these companies that are here. This is a great opportunity. So thank you. And we'll get started in just a minute here.
I was sitting on my computer the program collect the data. Processing is pretty like.
Amazing. Awesome. It's so good to hear you all chatting with each other and meeting people. So, by show of hands, I kind of want to not judge, but see the years of experience we have in writing Go and in the industry here. So, If you've been writing Go, or you're just starting to write Go, or you're in school and learning Go, raise your hand. We've got a bunch of new Gophers. That's awesome. If you've been doing it for maybe 1 to 4 years, raise your hand. We got a lot of them. That's great. And then what about 4 or more years? Wow. Anybody over 10 years of writing Go? Ooh, we got some pro Gophers here. That's incredible. Awesome. Well, I'm excited to introduce our next speaker, Takto, who flew this week from Tokyo to come and speak to all of you. And so I'll let him introduce himself, and I'm excited. Thank you.
So, thank you. Good morning, GoWest Conference. I'm Takuto Nagami, as Boston introduced, a university student visiting here all the way from Japan. So today I'll be talking about the fundamentals of memory management in Go, learning through its history. So let me start with a question, classical presentation technique, right? So how many of you are new to memory management or have ever struggled to learn it? Could you raise your hands, everyone? Not everyone, yeah. Yeah, so I see many of you raising hands, nice. So honestly, I struggled with the memory management too when I first learned it. It's actually tough. Why should we care about it, despite its complexity? Well, there are some reasons. First, knowing memory management helps you make your apps faster is a performance problem. Second, Go itself needs people who understand it to keep improving it. So if nobody knows about the memory management, who is going to take care of Go itself? And finally, it can actually be fun to learn Go memory management. Out of these, performance is the biggest reason, I guess. Cybergen, a Japanese tech company, once shared that just one small change in the memory allocation cut a CPU usage by 57% and the memory by 99%. That's massive, right? So I'll talk about this case concisely later. So if you've ever been curious about the memory management, you might have checked out some conference talks like Understanding Allocations, Memory Management in Go, the good and bad, Escape Analysis in Go, or Garbage Collection Schematics. But honestly, those can be really tough for beginners. Why are they? I think it's because of the how we learn things. I like to call it the why, what, and how process. So think about that. So when you add a new feature to your application, you start with why. Why do you need it? And then you move to what. What exactly is it? And finally, how. How will you build it? I guess the reason most talks are difficult is that they jump straight into how the memory management. That's great for advanced Gophers like pro Gophers. But for beginners, it's just too much. So beginners first need the why and the what of the memory management. And that's what I will cover today. So keep that in mind. I am here to tell you about the whys and whats of memory management in Go. So before we dive straightly into the memory management, so let's make sure that we understand two key parts of Go: the compiler and the runtime. The compiler's job is to take your Go code to turn it into the binary. So when you run Go build command, that's what happens. Your code is translated into something the computer can execute. So everything that happens before you run the code in the build time is a compiler's responsibility. Once you actually run the binary, the runtime takes over. The runtime runs together with the program. It is compiled together with the program and runs together, and provides features that only work during executions, like scheduling Go routines or so. If you've wondered what the Go run command is, it's just a shortcut. It builds your code and then immediately executes the binary for you. That's simple, right? So we understood the compiler and runtime. And let's talk about what memory actually is next, the starting point of memory management. So if you build your own PC, you've seen it. So memory is those electric chips called RAM, random access memory. Now, some of you might think of a hard disk as SSDs when hearing memory, but those are strange, not typically memory. So when we say memory, we usually mean RAM in this session. So when you run a program, the OS operating system splits RAM into the virtual memory for each process. I won't dive into details today, so just Google virtual memory later if you're curious. So you can think of the virtual memory as a key value store. The key is a memory address, and the value is a single byte. So unlike normal KV stores, the value size is fixed to exactly only 1 byte. when you write assembly, you work with this key value store directly. When writing data to the memory, you store the value at a directly specified memory address. And when reading from the memory, you retrieve the value from the address. That's simple. But this is actually painful because you would have to remember every single address while you're programming. That is a nightmare. Your brain explodes. To solve this problem, we now enter the era of variables using the concepts of stack and heap. So after the assembly era, the high-level languages appeared. So in 1957, Fortran, the first high-level programming language, is released, followed by COBOL, BASIC, Pascal, and C, and eventually Go. So with these, we gained powerful new tools. So many of the high-level languages, including Go, introduced variables as a form of data abstraction. When you declare a variable, say A here, the language somehow assigns it to some memory address. And the same happens when you declare B. As programmers, we just work with the variable names. That's perfect. We don't have to worry about memory addresses. That's a huge relief for programmers. But the language itself still has to manage where the data lives. The language can't just put data anywhere. It needs rules to place it properly. So we don't want to arbitrarily decide which memory address stores the variable data. Now, to make rules to place in variables, let's look at the function calls. The main function starts first, then it calls A, the execution moves there, A calls B, and the execution moves again. When B hits return, it goes back to A, same again, and finally back to main, and the program ends. This pattern is last in, first out. So the last function called is the first to return. So if you're an enthusiastic lead coder, you may have guessed it, is a stack data structure. And that's how the stack memory area was born. So let's see how variables are handled with a stack memory during the function calls. When main starts, the language creates a stack frame. A stack frame represents a function in the memory. Each frame defines a scope so that the language focuses on one function at a time. So here's a structure defined by the interface called ABI. You can search it on Google. So if you're curious, just Google it. So the important part is the variables declared in the main function go inside this frame if it is own data and address. And it gets tricky. So when main calls a function, the language knows the place where the call happens so that it knows where to return afterward. Then it creates a new stack frame for a function and moves the scope there. The language doesn't need to worry about the other frames at this point, like main stack frame. It just works with the current function. Before actually executing a code in the a function, the language knows the address of the previous frame, so it can come back smoothly. Arguments are copied in as variables. Then the code runs, and any variables declared in a function are stored in the stack frame. So when A calls B, the same thing happens. Note a call, create a new stack frame, store the previous frame's address, copy arguments, and run the code. That's simple. And when B reaches its return statement, the return value goes to the small CPU memory area, not a stack. I'm not going into the details about that. But after saving the return value, the B stack frame is completely erased, and the focus comes back to the A stack frame. So now the stack is A function. So control returns to A, which also returns a value, and its stack frame is then erased as well, and the return value is assigned to the variable in the main function, as you can see. So finally, the main finishes, all stack frames are erased, and the program exists. That's generally how stack memory area works. So far, stack seems to be perfect, but it's not a silver bullet at all. So stack allocations are determined at the compiler time, actually. Variables with unknown data size at compiler time, like maps or slices, as you can guess, are too complex to handle here. And stack isn't good for sharing variables between functions. You would have to copy variables as arguments one frame to another, so which makes the process slower. To handle the stack limitations, we use dynamic memory allocation, so-called a heap. So let's see how it works. When main function starts, its stack frame is created, as we see before. But if you declare slice, for example, here, the actual data goes to the heap. The heap is like an assembly memory. Data can go anywhere in the heap area. Unlike the stack, the language runtime decides the address. But here's the problem. Main function doesn't know where the heap data lives. So since the program focuses on main stack frame, it can directly address the heap data. And here's the solution. The stack stores a heap address in variable called the pointer, as we know. This pointer acts like a normal variable in the stack, letting us access and manage heap memory safely. This pointer is an important concept like talking about memory. Let's understand what pointers do with another example. So pointers are not just about a heap. So they're also the great tool for explaining the difference between the pointer arguments and the value arguments in Go. So with a value argument, when you call function, the data is copied into the function stack frame. Any changes inside a function only affect to that copy, and original variable in main stack frame stays the same. However, with a pointer argument, the function receives the pointer to the original variable in the main function. Now changing inside the stack function directly affect to the variable in the main. So this is the difference between the value arguments and pointer arguments in terms of memory. So far, we've seen how stack and heap together make a general purpose memory management possible. Let's go back to the heap for a moment. So in the old days, especially in C language, heap management was done with two functions, malloc and free. So malloc is a function to allocate memory on the heap and returns a pointer to it. When you are done with the heap data, you have to manually call free function to release the memory so that it can be reused. But what if you forget to call free after calling malloc? So as you can guess, the memory usage just keeps growing. So this is called a memory leak. And in the end, many of the memory leak happens, and the problem just gets killed by the OOM, the auto memory error. To solve this problem, engineers came up with the automatic heap management, what we call now the garbage collection. Garbage collection, also known as GC, basically cleans up heap variables that are no longer in use. So it doesn't touch the stack. This is purely a heap thing. The Go includes the garbage collector in its runtime. It uses an algorithm called mark and sweep. Here's how we can think about the memory now, talking about the garbage collection. So instead of a tall tower we saw before, let's imagine it as a simple 2D map, since we don't care about the exact memory address anymore. So how does mark and sweep actually work? In mark phase, the runtime follows the pointers from the stack into the heap. So any heap variables reachable from the stack are considered in use. For example, if the main stack frame has a pointer to A gets marked. B is pointed, B gets marked too, and so on. Now we see E is pointed from the D in the heap, so E gets marked too. Basically, every object reachable from the stack is marked as a line. Then comes the sweep phase. Anything not marked in this example, C, is cleaned up. That's it, a very simple idea. But optimizing this algorithm is a bit tricky. The Go team has been putting much effort to optimize GC. For example, GC now runs concurrently with your code using techniques like Dijkstra's tricolor algorithm. You can also tune the trigger of the garbage collection with settings like Go GC or Go mem limit. And in Go 1.25, the brand new experimental algorithm called green tea was introduced. This green tea is an algorithm that makes the mark phase even faster. Actually, Go doesn't chase overly complex algorithm to go above and beyond, like other languages does. So Go keeps its GC simple, which really shows its philosophy, not only in the language spec, but also in the runtime. So far, we've seen that garbage collection is great for programmers, but it also brings some pain. So placing a lot of data in the heap can make the GC expensive. It uses a lot of CPU, especially during the marking phase. Most garbage collected languages decide what goes into the heap based on the type. So in old Java, all objects created from the classes go into the heap. Python does the same. In JavaScript, all non-primitive type values go into the heap since it's not fully object-oriented language. So in many GC languages, non-primitive types end up in the heap by default. And this is where Go is different. Few languages, including Go or modern Java, has a special functionality called a heap escape to decide which variables really need to go into the heap. Heap escape in Go basically tries to keep as much data on stack as possible and only let variables that really need it escape to the heap. You might wonder, do we know which variable escape? The answer is, you don't. As Jacob Walker said at GoWestConf Singapore 2019. So there are some common cases where variable escape, like returning pointers, interface types, maps, channels, strings, and multiple slices. But beyond that, only the compiler and runtime truly know. Most heap escapes are determined by the compiler. The remaining ones are handled by the runtime. Though we cannot always imagine it, we can see how the compiler and runtime decides heap escapes. At compiler time, Go runs heap escape analysis to determine which variables should be allocated on the heap. So you can see the compiler's decision by adding the gc flags equals -m option to go run, go build, or go test command. This only shows the escapes decided by the compiler. For allocations, including those handled by the runtime, you can check them using benchmarking. So simply write a benchmark like this and run go test -bench package name and the package path and the -bench mem. So I brought some examples of heap escape analysis. First, a value returned from the function. It is a very common case that compiler says it escapes to the heap. And actually, benchmarking confirms it does by showing one heap allocation per operation. Next, the variable used only inside a function. The compiler says it doesn't escape. This pointer doesn't escape. And benchmarking shows 0 heap allocations, like you can see here. And there are some tricky cases. Sometimes the compiler says that the variable does not escape. Yet benchmarking reveals that it actually does because the runtime forces it to escape. So for example, a slice here doesn't appear to escape in the compiler log, like here. It says it does not escape, but benchmarking shows it actually causes one heap allocation per operation. So this is how we can observe how both compiler and the runtime handle heap escapes. By the way, let's take a quick look at how objects are all organized in the heap. So heap objects can have different sizes. For example, integers and pointers are 8 bytes, struct depend on their fields, and so on. To simplify the management, Go groups objects of the same size into the group called spans. So for example, here, span 1 might hold integers of 8 bytes, while span 2 holds structs or other 8-byte values, and so on. The grouping depends on the size of the values, not their exact types. Spans are grouped into M-central, and several M-centrals form an arena, and arenas together make up a M-heap, the complete heap area. This hierarchy helps Go manage memory efficiently. When we talk about the heap escaping, zero allocation is an important concept. Some libraries advertise themselves as zero allocation, but that doesn't mean no memory is used. So it really means no heap escapes. Data stays on stack instead of going to the heap. So there are several zero allocation libraries like ZeroLog, zero allocation logging, fast HTTP, partially zero allocation HTTP server, or GoReflect, zero allocation reflection, surprisingly. So you can make your own code zero allocation as well. But zero allocation is not a silver bullet. So since it avoids a heap, arguments often need to be copied to share data between functions. Copying large values on stack can actually consume more CPUs even if no heap is used. The key takeaway is that zero allocation is just a strategy. Always measure the impact with benchmarks and use the zero allocation techniques wisely. So the message here is understand heap escaping and utilize zero allocation libraries wisely. So far, we talked about the heap, but now let's go back to the stack. So here we have a stack overflow, one of the most well-known programming errors. So is a language, not an environment that sets a limit between the stack and a heap. So for example, on Linux today, the stack size in C is 8 megabytes. Calling too many nested functions, like shown in the slides, such as the infinite recursive loop, can exceed this limit and crash your program. And that's the Stack Overflow we all know. We've seen how heap escaping works and increasing the stack usage. And as you might also guess, the higher stack usage makes a Stack Overflow more likely. You might think the solution is simple, just prepare a huge stack area, right? It sounds good, but that comes with a trade-off. Allocating more stack space reduces the heap area, which can increase the chance of the OOM kills instead. And here is how Go solved the problem. Flexible stacks. In Go, each Go routine gets its own stack area, which can grow and shrink dynamically. So stacks are initially small, it's 4 kilobytes, and it expands as needed based on the Go routine stack usage. Here's a rough idea. So imagine the three Go routines, main and A and the B. A runs more code than other two and needs a larger stack, while main and B use smaller stacks, right? So Go handles this dynamically. So each Go routine only uses what it needs. Now, some of you may wonder how it is implemented. Originally, this was done by the segmented stacks, but this approach had limitations. Today, Go uses stack copying, the more optimized technique that quickly resizes stacks. So let's see how stack copying works in Go. Imagine this green box as a current main Go routine stack containing the main function stack frame and the M2 function stack frame. Now, if M2 calls M3, we need to add an M3 stack frame on the top. But as you can see here, it doesn't have enough space. What should we do? So Go detects a shortage now and allocates a new stack area for the main Go routine, double the previous size, in another area of memory. This box, upper box, represents the brand new main Go routine stack. Then all the existing stack frames are copied from the old stack into the new one, just like this. Once that's done, M3 can finally execute normally. And after returning from M3, the extra stack space is no longer needed, right? So Go just shrinks the stack back down. This dynamic resizing is what makes Go stack flexible, safe, and efficient for Go routines. Now, you might think that Go's flexible stack means Stack Overflow won't happen. But that's not true. Yeah, Stack Overflow still exists in Go. Each Go routine has a maximum stack size, which is 1 gigabyte by default. If a Go routine exceeds that limit, for example, with an infinite recursion in the function that I'm showing in the slides, Go will crash with a Stack Overflow error. So you see an error here, Go routine stack exceeds 1 billion by limit, and the fatal error, Stack Overflow. You can actually change the stack limit using a runtime such debug.setMaxStack function. However, since the default 1 gigabyte limit is sufficient in most situations, it is now recommended to modify it in the production. So flexible size stack per Go routine makes a stack in Go special. Understanding this also helps explain why Go routines are powerful. Now we're finally at the explanation of the example I mentioned at the start of the session. So as a reminder, this case shows that a single memory allocation change cut CPU usage by 57% and memory usage by 99%. This amazing blog was written by the Honoka Toda, a Japanese software engineer at CyberNet. So now, first of all, please give her a big shout out. I really appreciate Honoka for giving this amazing blog. So what exactly happened in this article? So she noticed the periodic CPU spikes in applications like this graph. After digging in, she found that the app created many short-lived heap objects, which triggered the garbage collector many, many times. And using profiling tools, she eventually identified the bottleneck, the filtering function. Here's what the filtering function looked like before the optimization. It's a simple function that filters elements in the list and returns a new slice containing the filter function. And you can see here that it creates a new slice every time it is called. And the heap escape analysis shows it goes to the heap definitely. Since this function runs frequently, it generates a lot of garbage and triggers a GC repeatedly. After the optimization, the function reuses the existing slice passed as an argument instead of creating a new one. So I ran a simple benchmark comparing the original and the optimized filtering functions. So using a list of integers from 1 to 100 and filtering even numbers. So as you can see here, the optimized function was twice as fast. And what's amazing is that this improvement came from just a single heap allocation, only one slice. In this blog, Honoka went further by using iterator, making the logic safer and simpler. And across the entire workload, the optimization led to the 57% reduction in the CPU usage and 99% reduction in the memory usage. This is a perfect example of how understanding memory management can dramatically improve your application's performance. So that was a dense 30 minutes, and we're finally wrapping it up. So memory management has evolved to meet programmers' needs, and understanding it gives you the strong power to optimize your applications. The key takeaway here is this session is just the beginning. There are many, many kinds of more memory management sessions. So if you're curious, dive deeper into the concept to each concept and explore the memory management further in Go. So thank you all for listening, and I hope you enjoy the rest of the conference.
Let's talk Go. Cool. Well, while we're transitioning over to Asini, yeah, come on up, Asini. While we transition, I do want to see who traveled the furthest to get here. I think I know the answer, but if you're here in the Salt Lake area, so within 2 hours, raise your hand. Yeah, majority, that's kind of what I guess. If you traveled over 2 hours to get here, we got some St. George, some further, nice. If you traveled more than, let's go 8 hours. Got him. I think Takto told me 11. How many hours did you go?
25.
25. So we're excited to hear from Asini. He came from Armenia, and he is currently at JetBrains, and he's going to talk to us about how they use Go there. So thank you.
Free? 1, 2, 3. Oh, amazing. Hi, everyone. I'm really happy to participate in this conference. And to be honest, I'm a little bit scared because it's my first public talk, but I will try to do all my best. And today, I want to tell you about one of the pain points of Go language, namely nil pointer dereference. And here we go. Okay? Go is pretty safe language, right? Go has garbage collector, so you don't need to worry about memory leaks. Go has escape analysis, so you don't even need to know what the dangling reference is. There are no dangling references in Go. Also, there is a nice concept of zero values, so you don't get undefined values and don't get undefined behavior, and it's cool. All of this makes Go pretty robust and reliable language, except for the one thing. Unfortunately, Go is not nil safe. And I think almost everybody have seen this message before, nil pointer dereference. And it doesn't matter whether you are experienced Go developer or just getting started and new to Go. It's really easy to make mistake while you are working with pointers and end up dereference a nil value. And when that happens, it can crash your entire application, break down your API, background service, whatever. And yeah, actually, a nil dereference isn't something new, and it's not Go specific either, right? The idea of null pointers was introduced back in 1965, almost 60 years ago, by Tony Hoare. And since then, quite a lot of languages like C, C++, Java, etc. Has adopted the same idea and fell into the same trap. And Go is not an exception either. Okay, and all of this has led to countless bugs, validation, and endless debugging. That's why later, in 2009, Tony Hoare called it his billion-dollar mistake. He pointed out that IT industry has spent quite a lot of money, billion of dollars, just fixing issues that relates to nil pointers. And yeah, unfortunately, it's not something from the past. It's still happening, even in Go world. Not long time ago, a Go developer shared a story how his company lost $100K, and it's because only for 1 billion or for one nil dereference. And yeah, so it's our reality, and it happens nowadays. Okay, now let me share why I'm interested in this topic. I'm software developer at JetBrains, and I'm working on Golang IDE. And I'm passionate about static analysis tools. I love developing different kind of linters, analyzers, checkers, and stuff like that. And in particular, for the last time, I've been developing a nil dereference analyzer to spot nil dereference issues specifically for Go language. So that's why I'm here, and I want to share my thoughts and experience with you. And today, I want to cover the following topics. Firstly, we will refresh our knowledge about nil values in Go. Then I will show you subtle and interesting code examples that relates to nil dereference, and we will investigate them together. And finally, I will show you some tools that can help you to detect and prevent nil issue early. Okay, let's start with the nil basics. As you know, in Go, there are 6 types that can hold a nil value. They are pointers, interfaces, slices, maps, channels, and functions. I'd like to call such types nilable because their value can be nil. Okay, and once we have a nil value, we should be extremely careful with it because almost any operation on nil value will lead to nil pointers and panic and runtime. For example, we should not dereference a nil pointer. We should not access field of a nil pointer called method on nil interface, index nil slice, and so on, so on. So there are quite a lot of operations we shouldn't do on nil because we get a panic at runtime. Also, we shouldn't read or write to a nil channel because it will block our Go routines forever. And yeah, besides this unsafe operation, there are several safe operations. For example, you can add something to a nil slice, take it length, and so on, but it's kind of exception. Let's skip them. Okay, and that's it about nil basics. And now let's move on to the fun part and break some code. And I need help. Yeah. Thank you very much.
I thought you were going to be the one breaking the code.
No, that was my talk.
Okay, do you see code well?
Yep.
Okay, let's start. In this section, I will show you some examples of nil dereferences, and I will investigate them. So let's start with warm-up example. And here we declare a config variable C, and then we set its fields. And as you may guess, if I run this code, it will fail. Let's check it. And yeah, here we get a panic due to nil pointer dereference. So let's figure it out. Actually, if we declare a variable in Go, without initializing it, it's assigned to its 0 value. And 0 value of all nilable types is nil. So the variable C is default initialized to the nil, and then when we try to set its field, we get a panic. So to fix this issue, we need to initialize it. Let's do it. Yeah, and let's simplify code a bit. Okay, now it looks pretty fine, and we fixed this issue. Let's check whether code works now or not. And no, it doesn't work because we have another issue. Actually, we get a panic due to assignment to entry in nil map. So what happens? We initialize the variable C, but we don't initialize its fields. So that is, the options fields is also default initialized to nil. And when we try to try to write something to a nil map, we get a panic. So to fix this issue, we need to initialize this field like this, and now everything should work. Yeah. Actually, although it's a toy example, but you can make the same mistake in your real code because it's really easy to add some nilable field to your struct, then forget to initialize it somewhere in your code, and eventually you will get a nil pointer dereference. So instead of initializing struct like this, we can extract it to a constructor. Okay, and let's move on to the next example. Okay, and this example, here is example of the real code. I extracted it from the real project and simplified it a bit. So it's not a toy example, it's a real bug. And yeah, what happens here? First of all, we try to load config from the file. And if it fails, meaning that config is nil, we try to load it from the environment. And if it still fails, meaning that config is nil or error is not nil, we return immediately, okay? And otherwise, if we manage to load it somehow in either way, we just print it to the console. So this code looks pretty fine, but there is a hidden bug here. Actually, let's figure it out. So there are two different config variables. This config variable and this config variable are different. They are not the same. In Go, we can declare a variable with the same name in the inner scope, like this. And then this variable will shadow the variable from the outer scope, this one. And that's why it doesn't matter what we do with config variable here. It doesn't affect the original one, right? So let's imagine that load from file return nil value. So the original config is nil. And the load from environment returns some not nil result without any error. And in this case, we don't return immediately. But the original config is nil, so we get a panic here. Let's check it. And yeah, so we get a panic because of potential nil, because of nil pointer dereference. Okay, and this bug is really dangerous because most of the time your program works correct. So, and only in some cases the nil dereference can happen. So I just want to highlight here that we should be careful with shadowing of variables, and sometimes your IDE can highlight that this config variable and this config variable are different. I don't know whether you yeah.
You can see.
Yeah, cool. Nice, let's move on to the next example. And yeah, I really like this example because if you encounter it for the first time, most likely you will spend quite a lot of time investigating it, like me at the first time. So here is quite straightforward code. We just load file, and then we want to validate its content. And if it correct, if content is valid, we just print file is valid. Otherwise, we call a panic. So everything pretty straightforward. And now let's consider the case when validate file returns some nil error, So validation is success, and so we expect the program to print file is valid. Yeah? Let's check it. Oh, something went wrong. Actually, we get a panic with the message error is not nil, file is not valid. And it's really strange because we return nil explicitly. From here, we return nil error. And so this condition should be false, and we shouldn't enter this branch. But for some reason, something went wrong. Okay, and to understand what is going on, let's take a simplified example. Here, we declare our custom error variable of pointer type, and then assign it to nil. And then we assign this variable to error variable of error type, and we want to answer the question whether this error is nil or not. So, as you may guess, if I run this program, this error will be not nil. It's also confusing because we assign it to nil. So, and let's figure it out. Actually, in Go, any conversion from the pointer, from any pointer to an interface value results in a non-nil interface value. It doesn't matter whether the pointer is nil or not. The result is always not nil interface value. It relates to some internals of how interfaces are represented under the hood, but it's out of scope of this talk, so let's keep it. But let's remember this rule. So now we can get back to the original example, and now we can investigate it. So here we have a pointer. So it's a pointer of validation error. And we have an error, and error is something of interface type. So here we have an implicit conversion of pointer to an interface types, and that's why the error variable is not nil here, and we panic. So yes, actually, it's really confusing. And my main point here, so first of all, we should know that any conversion of a pointer to an interface results in a not nil value. And the second point is that we should never use a custom types of error as a result functions, as a result types of the function and method, because it's leads to bugs, obviously. So instead, we should do something like that. And now we fix the issue, and now file is valid. So because we don't have this conversion anymore, right? So let's move to the last example. And in this example, I want to show you that sometimes it's almost impossible to spot the issue because you may not have the full context. So here you can see a pretty straightforward code. We just create a new user, we just create a new user using new user constructor and then print it to the console. So this code is pretty straightforward and it's definitely correct, but can we get a panic here? So let's check it. Yeah, we can get a panic here due to nil pointer dereference. And it's confusing because this code looks fine, right? And to understand what is going on, we need to dig deeper and take a look at the body of the new user. Okay, now we can see that there is something strange here. In some cases, for some reason, constructor may return nil value, and it's not idiomatic code, right? If we want to return some bad value like nil, we should return the error, not nil error as well. So let's fix it like this. And let me move this function to the main file just to see the full picture. Okay, and now we need to handle error here. Right, so cool. Now we have a correct code, right? Because so we improved our code. We return result together with error. We handle all errors properly and propagate them properly, and we handle errors properly here as well. So this code looks fine. It looks like idiomatic Go code, and it's definitely correct. So, but I have the same question. Can we get a panic here? Actually, let's try. Nobody knows, right? Yes, we can get a panic here, even in this code that is correct. Believe me, this code is correct. And to understand what is going on, we need to dig deeper once again and take a look at the body of create user. And only now we can spot the original issue, the root cause of the issue. It's return nil nil statement. So here we return a nil result together with nil error, and it makes a nil result valid. So it doesn't matter whether we handle errors properly. The nil-nil pair propagated throughout our program, and nil reference happens here. So we can fix it, like introduce, like return not nil error, say this one. And now we finally fix the issue. Let's check it. Yeah, cool. So my main point here is that we should not use return nil-nil statement because it's also source of such bugs. And the second statement is sometimes it's quite hard to spot the issue because you may not have the full context, the full code. So you can see only some parts, but the root cause of the issue can be located far away from what you can see. Okay, and Actually, that's it for the coding part. Let's return back to the presentation, and thank you very much for assistant. Okay. Now I'm hearing myself. Okay, we have considered several interesting and subtle bugs that relates to nil pointer dereference. Now let's take a look at tools that can help us detect and prevent such issues early. So here we go. To detect bugs early and automatically, we can use static analysis tools. And there are at least 3 such tools in Go. They are GoWet, Static Check, and GoLand Lint. Each of these tools has checks for different kinds of bugs, and that's why I call such tools general purpose. And in particular, they have checks for nil dereference. For example, GoWet has a nilness analyzer that can spot some kind of nil dereferences. Okay. However, all of these checks are pretty straightforward. They can spot only simple bugs or common mistakes. For example, they can spot issue in the left. It relates to the default initialization, but they cannot spot the issue in the right. And the right example shows an important limitation of all such analyzers. All such analyzers perform only local analysis. It means that they analyze each function separately in isolation, and so they cannot reason about anything beyond the current analyzing functions. And that's why, for example, they cannot understand that function foo returns nil, and so they cannot spot the nil dereference here. Although this example is really simple, right? Extremely simple, but they cannot spot them. Okay, and this local analysis is not enough for detecting real nil dereference issues, and because in the reality, the nil value creation and its corresponding dereference can be located far away from each other. They can be located in different functions, in different files, or in different packages. And to spot such issues, we need to perform more powerful analysis. So, and the good news here is that we have 2 advanced nil dereference analyzers. They are NilAway and GoLand nil dereference analyzer. So, NilAway is developed by Uber team, and it's designed to work offline, for example, during build time or in the CI/CD pipelines. GoLand analyzer is developed by mostly me and other guys from the GoLand team. Woo! Thank you. So feel free to ask me anything about it. I'm really happy to share its internals. And yeah, this GoLand analyzer is mostly developed to work on the fly in the IDE, so it can spot issues while you are typing your code, like a regular inspection in the IDE. Okay, and both analyzers perform deep interprocedural analysis. It means that their analysis is not limited to a single function, so they can analyze kind of whole project, and at least they can understand how nil values are propagated throughout your program. Thus, both analyzers can spot more subtle and more interesting issues in your code, and in particular, they can spot almost all issues that I've shown to you previously. Okay, now let's briefly take a look at how it works in action. I need assistant, please, once again. Thank you very much. Sorry for bothering you. Okay, and let's take a look at GoLand Analyzer first. I need to enable all inspections in the IDE. Then let's introduce the bug again. And yeah, here we go. So here is the last example I've shown to you previously. And as you remember, the root cause of the issue is located far away from the place where nil, this one, return nil nil, is located far away from the place where nil dereference happens. And what?
You're good. You're good. Right there.
Oh, okay. So, and as you can see, GoLand Analyzer manages to spot this issue, and moreover, it can show the full path from the nil source, from the root cause of the issue, throughout your program to its corresponding nil dereference. And yeah, now let's take a look at NILAway. So actually NILAway can do the same. You can run NILAway from the terminal like this one, and it also can spot this issue, and it also shows the full path from the nil value creation like this, and its corresponding dereference. So as you see, both analyzers can track how nil values are propagated throughout your program, and that's why they can spot hidden and more interesting bugs. Okay, and now let's get back to the presentation. Thank you very much. Okay, we have considered several static analysis tools, and I encourage everyone to check them out, all of them, and maybe even use them in daily life because they can all save your time as well as mental health. And
Money.
and money, of course, yeah, 100K. And that's it about detecting and preventing nil issues. Now let's move to the conclusion. And let's summarize what we learned in this talk. First of all, we found out that nil dereference is still serious and risky problem, even in Go world. Secondly, we saw that it's very easy to run into the nil dereference. We investigated several subtle bugs related to it, so we should be extremely careful with it. And finally, we looked at several static analysis tools that can help us to reduce the number of bugs in our program. So, and I encourage everyone to use them, Golang CI, GoWet, and stuff like that. Okay, and to wrap it up, let's be careful with nil, use tools to catch bugs early, and make our code safer. So that's almost it. I just want to leave some resource for you. If you want to get examples that I've shown to you, you can use this QR code. And also, I won't suggest you to read this book, 100 Go Mistakes and How to Avoid Them. It's really interesting book. There are quite a lot of subtle and interesting cases regarding the Go language, not only about nil dereference, but about everything. It's really interesting and it's worth reading. So that's it. Thank you for attention.
That was awesome. We actually have time for maybe 1 or 2 questions if anybody has a question.
Sorry. Yeah, I've been quiet so far. So you did the example of returning the custom error. I wanted to clarify, it's okay to return a custom error struct as long as your return type is an error, right?
So could you repeat, please, which example?
You return in that error,
Uh-huh.
and originally it was a pointer to a...
Yeah, original to pointer, yes.
If you did that, you changed the return type to be error.
Yes, to interface type.
Still fine and would not introduce a bug to in the code, return a pointer to your custom struct type.
Yeah, I guess.
Is it the conversion that's the problem?
Yeah. It's the type in the return.
It's the type in the return, but it's canonical to return custom errors as long as like the return type is not.
Yes.
It's
So
not
set
it's
aside
not
the
a,
interface.
Mm-hmm. Yeah.
Alright, cool.
One more?
Yeah, sure.
Yeah.
Is this something that you could put into the compiler? So the Go team could put into the compiler?
Oh, it's a really interesting question because I have read 3 proposals of introduction annealable types to Go compiler, and they all were rejected. And most likely, the next one will be also rejected. So I don't think so. But I'm really interested in it because it will be nice. I think it's possible. So, and as I know, the main point from the Go team why they don't want to introduce nilable types and make Go nil safe is that, like, the first point is simplicity. The second point is backward compatibility. So yes, and that's it, I guess.
Awesome. Thank you. For us to break for lunch, some few logistics about it. There's 2 lines. There are drinks in this room with the store, and definitely as well, we have corn tortillas for those with allergies. Please don't take those unless you have it, and then if there's extra at the end, you can go and grab some. But we're going to break for lunch. Afterwards, we will have lightning talks. I will post the schedule of the lightning talks during lunch onto Slack, so keep an eye for that if you did sign up. But otherwise, chat with people, and we'll see you in just a little bit.
1 o'clock.
1 o'clock. Yeah, 1 o'clock. All right, let's take some seats before we get started with the lightning talks here.
That's credential.
That's
This job, those pipeline has access to these secrets.
that's really cool.
All right, so I put the lightning talk order in Slack. So first we have Aaron Crowder. Is Aaron here? Yes, I will. I was just hoping to get Aaron up here so we can get them set up. Is Aaron here at all, or do we skip Aaron?
There's still plenty of people out there.
Go yell at them. Thank you. So a few other things is we do have a raffle with some sweet prizes that you might have seen on the snack table. We will raffle at the end, and there's no need to entry. Your ticket was your entry in for that. So that will be awesome. And then we will have after party. You have to be present. Yes. So cool. And then we're still looking for Aaron. Otherwise, we're going to skip him.
Let's get next time.
All right. We might come back. AJ, I know I've seen him here.
He's just talking out there.
Oh, my gosh.
You'd like take a picture. Send it out.
AJ!
Trevor, this is close.
I'll start chanting for him and get him in here. Hey, Jay.
It's just it's just
We'll give people a minute to walk back in here, I suppose.
It's also easy to have a call on this.
I knew that they had some stuff, but it's like, because we use GoVet. I didn't know about any of the Okay, it's good, right?
I got warning pipeline that like it's Dino Freddy like good by Uber's team. I spent the whole time
She's scared to run it on our back end right now.
I'm now notified. I didn't talk to him. I don't know how I get that to like that. You guys went on here.
Right now, I
All right. We will start this again.
I can imagine that the licensing.
We'll start with AJ.
Are you nervous? I'm very nervous. Shaking. I'm shaking. I am shaking. It's the caffeine. No, it's the nervousness.
Sweet. So please, if you are giving a lightning talk, take a look in Slack to see your order and come on up right before your talk. And then as well, I'm going to keep you guys to somewhat of a time limit of 5 to 7 minutes each. So if I come interrupt you, be nice, I guess. Cool. Well, first we got AJ.
Not ready.
Not ready?
I need to figure out how to get the screen to. I clicked on the wrong thing. Screen mirroring?
Yeah, you want mirroring.
I want me to change. Right there. Yeah, that's what I was trying to, sort that out before I got up here. Microphone too. I don't need a microphone. Do I need to use the microphone?
Yes, for the stream.
Okay, apparently I need to use the microphone. All right. Hold on. Let's do this right. Water. Don't do that to me, man. All right, we're gonna go straight into present mode. And slides aren't ready because I didn't even know if I was selected. How do I get into present mode these days? Where'd they move the present mode button? Yes. Anybody know?
I think this is good enough.
All right, it's good enough. Okay, so this is an IP address. It kind of looks like an IP address because you can tell there's an IP address in there. Everybody's seen one of these URLs, yes? Okay, come on. You've seen it. You've seen the AWS URL, the S3 URL. You've seen the IP. Come on. No, it's not just 3 people. All right, we're moving on. Okay, so this is an IP address. Okay, where do you see these kinds of IP addresses? Well, you see them all the time in web apps. You may have noticed that you see them in your database connections, like your Postgres app. You probably haven't noticed because you're Go developers, but Microsoft SQL Server does this. Another thing, Azure files, also known as Samba, all of these things can be reached via an IP address and a domain. Why are we talking about this? This doesn't make any sense. Well, first, I'm AJ, and yeah, that's me. And now we'll move on. There's a problem. There's only 4 billion IPv4 addresses. And the title of this lightning talk is TLS is better than IPv4. So now you have the context of the missing first slide. So there's 4 billion IPv4 addresses. There's about 8 billion smartphones. And there's about 50 billion websites. Okay, so just do the math, carry the 1. But wait, let's remember. IPv6 is going to fix this. Oh, that's not the right slide. Yeah, IPv6 is going to fix this because you've got 128 bits. So that's 32 bits for your ISP. Oh, and then your ISP takes the other 32 bits that are supposed to represent which networks that you can get. They're just going to take them all. Then you're going to get 64 of nothing, but you will get one usable address in your 64-bit address space from your ISP. So that's good. That might be one more than you got previously. But this is how the IPv6 breaks down. In theory, there's 64 bits for networking, and you should get some of them, like some of them. In reality, you get one. There's 64 bits for addresses. In theory, you should get all of them. In reality, you get one. So this means that but it's not a problem. Oh, I can't zoom in on this? Oh, I can. But don't worry, it's not a problem. IPv6 isn't a problem because Cloudflare is boasting that 15% of their traffic goes through it. So after, what has it been, 30 years, nobody uses it, so we don't have to worry about that. So that's a non-issue. All right, so we're gonna move on. And I don't know what order the rest of the slides are in because I just copied them in, so we're gonna roll with it. So actually, I'm gonna move this one here. This is my domain portal. And you'll notice here that there's only one actual IPv4 address that's a real IPv4 address that's publicly routable. And you'll notice that there's a bunch of other IPv4 addresses. How did I do that? Okay. So what if you could have all of your services that you want routable on the public internet just using IPv4? Just what if you could turn that 4 billion addresses into an infinite number of addresses? Well, it turns out that you can. And you only need one port to do it, and that's port 443. How can it be? Well, you may have heard of HTTPS, which is backed by a protocol known as TLS. And behind it, it has protocol. So in the old world, IPv4, we had port numbers, and you only had 65,000 of them. But in the new world, we have TLS, and you have what's called application layer negotiation, and you can have an infinite number of these names. And so if you look at TLS packets, you'll see things like HTTP 1.1, or H2, or WebRTC, or FTP, or IMAP, or POP3, or Jabber. Well, actually, it's called XMPP. But like lots of protocols that you know and love have a name, so you don't have to worry about the number. Everything can run over port 443. And then, not that one. Nope, not that one either. So anyway, the point of all this is, now let's go from franticness to actually making something that makes sense. I'm going to go back. So how this relates to Go, Go has excellent networking utilities, and I actually wrote a TLS router in Go. You could do it too. There are some gotchas to it, but every cloud service provider is using this. They're not using Cloudflare tunnels. They're not using these super complicated setups. On their side, they listen on port 443. They take in an IP address and a domain name, and they can route that IP address and the domain name into the private space, and you could too. So, sorry, this is a lightning talk. I don't have much to prepare and make it make sense, but if that's interesting to you, feel free to talk with me about it, because I think that it's great that we can solve our problems of making things routable on the public internet simply using a standard that's existed for a long time, is supported by all major providers, and You don't have to have really, really complex DevOps setups. You can have things as simple as, instead of putting in an A record for an IP address that you don't have, you can have one IP address, a whole cluster of things behind it, and then use CNAME records or similar techniques to be able to, or SRV records, et cetera, to be able to route stuff behind it. Sorry I took up so much time there. You're welcome. Good night.
Perfect. We could do one question.
I can do one question. Who's got the best question? Is it you? How's your day? I'm not answering that one.
Is it the same as like a virtual private cloud, like what you're trying to do?
Virtual private cloud is not exactly the same, but you can route things to a virtual private cloud through TLS. And that's what all the cloud providers do.
Thank you, AJ. That was awesome. Spencer Tuft. Is Spencer here? Great. AJ, do you want your laptop?
No. It just seems like it fits there really well.
Woohoo. All right, you should have a microphone. Thank you, this will be Spencer.
Yes, it is. Okay, let's get going. Don't ask me to set up my keyboard. Here we go. All right, I'm Spencer Tuft. I'm a software developer at BYU. Been there for almost 10 years now. 2 of those were as a student developer. We primarily, at that time when I started, were developing in Node.js. Before that, we were developing in C and PHP a little bit, and a few other languages, Java, Kotlin, were interspersed there. We do some Swift, but our main languages were the C, C++, and then Node.js. And that was a mistake, to say it bluntly. And these were the pain points that were driving us to change away from that. And in the last year, we made this switch to Go. We had too many frameworks to work with, and they kept changing too fast. Just today, I got a newsletter that said we have a new version of Next.js and Vite, so go upgrade to the next major versions, I guess, if you're doing that. But not for us. And ESM versus CommonJS, it just was getting out of hand. ESLint version 9, terrible, breaking change, and not compatible with any TypeScript plugins that you'd need. So a lot of TypeScript confusion started happening. Security fatigue. NPM has a lot of open CVEs, and Go has had way, way fewer. And that's a very attractive outlook for a language when your goal is longevity, like a university. Oftentimes, we touch an application, make some changes, and we don't touch it for months and months. And then a developer will come along and they want to add a feature, and they can't because the pipeline's broken, the build's broken, the tool chain's broken, needs to be updated. And now we're stuck in 2 or 3 weeks of maintenance before we can add a simple button to a page. So that just wasn't sustainable. So we needed I'm going to skip a few of these for time. We already talked about CVEs. Another attractive thing about Go that we really liked was all of the built-in features. We don't have to battle about which formatting to use in our code anymore. Just use whatever is built in. The testing library is built in. Anyway, less bike shedding, faster onboarding. That's the gist for that. It was faster to start up our Go containers than our Node containers, so that was fun. We were faster at responding to requests than we were with Node. You can see we rewrote one of our systems, our registration cart system, and we were able to process 34,000 items in a minute versus 18 items in a minute. So that was fun. Yeah, huge. Backwards compatibility, again, along the lines of longevity, we really could not afford to have breaking changes in our ecosystem every few months. And when Go has this promise of backwards compatibility for version 1, we really like that, and we hope to emulate the same in our shared libraries, to not have backward breaking changes. Smaller dependency graphs, Go's clarity and minimalism makes it easier to read and easier to onboard new students. We have a lot of student hires at OIT, or Office of IT, and so we have better training outcomes because we're more consistent in how we develop Go code. Some of the student feedback was that Go felt more intuitive than TypeScript, and they liked that a lot of the built-ins. All of our students liked the built-ins, and then Node had lots and lots of packages for the same functionality, and that confused a lot of our students as well. They were asking questions all the time about, when do I pull in this library and when do I pull in that library, and they're supposed to accomplish the same thing, but they do it different ways. So lots of questions. Hiring Node might have better hireability, but Go is steadily rising. And with the advent of AI into our public spaces, AI produces much more consistent Go code than it does JavaScript. Some of the drawbacks, we have some assertion libraries that there's a lot of assertion libraries in whatever language, but Go still has that issue. Not terrible to write your own little wrapper if you want. Decimal types, router quirks, there's some routing that has had some changes recently in the Go ecosystem, so we like those changes. We want to see more of those. And internal utility packages, auth, form helpers, sessions, we have to make some of those decisions, either to adopt third-party libraries or make our own. But again, far fewer than if we were in a JavaScript ecosystem. Training materials became easier because you've got a lot of great training materials already in the Go ecosystem, thanks to its narrower scope. And we've started to even further narrow that scope by developing our own opinionated framework within our Go ecosystem. Just the BYU packages and libraries that we use, so we bring them all into our projects consistently. We use the same tooling, and that's our framework, but it's just a narrower version of Go. We don't allow anyone to just bring in whatever package they want into our projects at BYU. They have to be approved. So that's it for us. Our path forward is our Go framework, secure by default, maintainable, we're looking to the future with more sustainability and faster deploys. Thank you.
All right, next we have up is Zach Walton, who's going to talk to us about juggling.
Yeah, I actually need someone else. Is anyone good at juggling?
I can kind of juggle.
Kind of? Anyone else? Anyone really good? Come on up. Perfect. Let's get you set up. Morning, really quick. No, I did not make this presentation. This presentation is brought to you by OpenAI's Atlas.
Side note, I think Zach has given a lightning talk at almost every West you've done.
I have, and they've always been about AI, and they've always been terrible, I think.
Okay.
But that's my favorite part about it. Okay. Am I even showing it, or am I?
Just plug in, did you? Okay, now it's mirror extend. Apple be an apple. There we go, you're on.
Okay.
You have a microphone.
Oh.
I do.
You can see your screen in the back as well.
Oh, you're right. That did not go to the right screen.
So now it's extending, not mirroring.
Command P for this. What do you do for that?
Go to settings and switch to mirror.
Somebody gave you drop it like. No pressure. It's not
Somebody's been dropping these all day.
I wasn't going to. It's already been done. It's just turning them into applesauce indirectly.
Yes, you would be loud. You know your child. I don't need the
Thank
notes
you,
anyways because I don't know
for
the
knowing
notes.
the
Yeah.
new OS.
Yeah, so like I said, there's gonna be some interesting things. This is, oh yes, you're right. This is a presentation by Atlas. The way I did this, I had a conversation first, but this is kind of the point I wanted to talk about, the metaphor between juggling and how it makes me better at using AI tools. So let's go ahead. I'm sorry, what's your name? Porter. Porter is going to juggle for us right now. And as you notice, as Porter is juggling, yeah, it's... And the thing that's really interesting about this is Porter's actually only doing two things. He is catching and he is throwing. Well, sorry, he is throwing. He is doing one thing. He is doing two things: catching and throwing. And the rest of it, gravity is doing, and the apple is doing for him. The action. So this is what I wanted to talk about: is that sort of metaphor. And why would you never? There we go. The first step is to catch. These are great. In this method right here, I actually switch my agent to ask mode, typically if you have different modes for your agents. But right now, the first thing to do is you must gather context. You must be confident that what you're gathering, that you understand it, and you can hold it. So that's when he's grabbing it, he's confident, he knows where it's going, he's grabbing it, gaining context. This is where I spend most of my time with AI. I ask not to clarify my understanding, but to build context to ensure the AI understands. I'll ask clarifying questions like, does this slide, and this is when I ask for this, does the image in this slide help convey what I'm trying to send? And the AI asks itself that, let me think, you're trying to answer this, and then it answers that. So then when I move on to this next phase, it has context. And this next phase is the planning and the throwing. As you notice, as he lifts it up, this is the thing that gives it the momentum, but it's still the only other action he takes. Planning is crucial. If you are not using planning in agents and you are coding that way, you are probably spending more time debugging than you'd love to. And what we can do with this, and what I've seen others do, is you take this time, you take the context that you've asked it and you brought in, and then you say, give me a plan. But not just give me a plan. It needs to have context accessible. I love to put these in markdown files. I've seen some do folder structures, but as this happens, you're giving it this concept to plan in. This isn't any real work. You cannot run any of this, but it is setting it up to break this down so that it can go well. When he is throwing it up, if he was throwing it to the left, he has no chance of catching it. He can throw it higher, but his actions have aim and they have momentum. That's what he's going for, yeah. So he knows where it's going to land, and that's how we need to do our planning. We need to know where we need to get better and eventually know where this plan should lead us when we need to catch it again. After we plan, we just let it go in the air, and it acts on its own. This is where AI is doing its own thing. It is actually planning. Atlas, when you see it do, it'll click around. It takes forever, but it is actually doing your actions. These are the tools doing the work. And the interesting thing about this is if we were to add one more ball here, a lot of the complexity, what changes about what he does? Does any other actions taken? Or is he still just hopefully catching and throwing, right? Same two things. Nothing changes except he has more to do. He has more tools in the air. So you can have as many AIs in the air. In fact, this is, oh, I guess there was a slide before that. And here's the best part about this. When you're juggling, how often do you juggle? Okay, so it's not like juggling. So how bad did you feel that you dropped the apple? Was that a devastating moment? Is your life over?
A little bit, yeah.
I wasn't gonna say it. They were all thinking it. You're correct. No, but the main thing is nothing matters other than you pick it back up and you start juggling again. That is it. That is it. Nobody cares. Everyone thinks it's cool that you're juggling anyways. When you drop it, that was the expectation. We're good. And here's the interesting thing about juggling is the scalability, right? Again, what is he doing? He is catching, he's throwing. But if you want more to do, you have to throw harder and higher with the same precision, knowing where it's gonna land. And when you catch, you'll notice he actually catches it and cradles it even more. There's more momentum. So when you catch after you act, you still have to ask again. The momentum keeps going. When your agent finishes, now you are asking and ensuring that you and the agent both have accurate context. From there, you don't need to be juggling that ball anymore. You can toss it aside, or you can keep juggling it if it has more processes. In fact, this is the style I did this in. And here's the rules to do this and kind of how I do this. The only rules are, you only have two hands, and you're always catching and throwing. And those are the only two things you can do at once. But you cannot catch and catch, and you cannot throw and throw. So you can only catch and only throw it once. But you can pass and switch off. So once he's done, he can ask on this hand, and he can throw on this hand. But now this hand, it can't catch until it's thrown, right? And once it's free is the only time it can catch. So those are like the methods. You can ask, you can plan, but you can only have one agent in each of those. And once you're done with that, you move it through the cycle. Ask, plan, act, ask, plan, act. And that's how it works. And it keeps going through that cycle. Did I just lose the mic? I just lost the microphone, but that probably wasn't my fault. No, it's not. I think it's dead.
You think it's dead?
Well, hello?
No, switch them.
I think it has no will to live. I'm not sure if it's... Thank you so much. These are my sources cited. This was all actually done in Atlas. I had a conversation with it. I had it literally just on the side. Oh, will it show me? This was, if it loads, it'll show you my whole, this was the conversation I had to make this slide. And it only took me since 9 o'clock this morning. It was not faster. So, but here's the thing. This is the important thing and why this matters. Dora metrics and plenty of white papers have proven that you are all slower because you use AI if you're coding with it. If you're only using that one tool and only coding, that instance of your coding is slower. You have to like look what it reads. You have to do all this stuff. The only way to get faster is to scale horizontally. If you can't work twice at once. AI can. You can have many AI tools going. And if you're slower on just looking and reading and doing that, that's fine. You have 3 other things going on while you were doing your one job. You've never been able to do 4 jobs at once. Now you can. And that's where this magic is allowing certain things while they're acting, you can get more balls in the air and you end up doing way more than you ever were because you're not faster with AI, but you are able to be more multimodal and more multitasking. There you go.
Add applause. Awesome. Next, have Ulysses Flynn. Did I say that right? Awesome. He was going to talk to us about security, which will be very cool.
All right, can everybody? Hello. Okay. My name is Ulysses, and this is not your typical security talk in terms of software. This is more hardware. I love embedded devices and hardware, so this is kind of a talk about security. Biosecurity is not encryption, even though people like to pretend it is, but it's really not. So let me get started. I know since you guys all know about garage door openers, right? You guys are all pros. I'll give you a little context on kind of what happens when they invented garage doors. So the first models were kind of just really simple, like, hey, I'm gonna set some dip switches on this controller, I'm gonna set some dip switches on the garage door opener. Great, now I can push it and it opens the door. The problem is that's not very secure, right? Because somebody can just capture that signal and replay it, and now they can open your garage door. So not too great. So what happened is the industry created this thing called Security Plus version 1. And so they thought, hey, we can fix this by just adding this idea of a rolling code. So basically, you would tell the garage door opener, here's the serial number of this remote, and here's some rolling code that we're gonna increment each time that you open the door. So what kind of ends up happening is that the garage door will check that serial number and that rolling code, and if things look pretty good, then it will basically say, yep, okay, I've recognized you, I'm gonna open the door. But what happens if you push the button a bunch of times, right? How many of you have been like, open door, open, right? Push that button and it doesn't work. So to kind of account for that, they basically don't check the exact count. They basically check like a range of like, hey, if this count is within 255, you're good to go, right? And then it increments the number. So while it's safe, it's really not that safe because who here has heard of a flipper zero? Or the hack RF, right? Like with these devices, it's really easy for you to capture that rolling code, that serial number, and you can replay this. So like there's been attacks where like what happens is like if I'm out by your house, I can have a device jamming your button signal, and then I can capture that signal, and then I can use it to be like, oh, I have some good rolling codes that the user hasn't used. I can replay those and open the door. So that's kind of a problem, right? Like that's, this is better than nothing, but still not great. So what ended up happening was that the garage door industry said, hey, we can fix this. We're going to create this new security 2.0. It's going to protect against this kind of attack. And what's funny is from their own patent application, it says a rolling code transmitter is useful in a security system for providing secure encrypted RF transmission. Hey, encryption, we know what that is, right? That's secure. We do banking and, that we feel good about that, right? But the reality is different, right? Because even though they'll say the word encryption, doesn't mean they're actually using cryptographic security. So what's actually interesting is that if you look at the patent application, you'll see that it's just bit shifting, XORs, some bit inversions. It's just some magic, or like we like to say, security by obscurity. So there's a really cool repo that I have here on my slide, and it's basically somebody that's taking the patent application for the security system, plus done some reverse engineering, and now you can talk to these systems. So this is kind of fun where I basically did this at home. I have a Hack RF. It's like a little hardware device, software-defined radio. Downloaded this code and was able to capture. There's two numbers here. I don't know if you guys can see that. Maybe I'll zoom in more. Let's see if I can do that. Nope. Can you guys see this number here that says rolling and fixed?
Yep.
So the rolling number, that's the number that keeps getting incremented by 1. So basically, once I captured this fixed code, that's the serial number, and I have this rolling code, all I have to do is add 1, transmit that, and open the door, which is kind of what this command does here. It's basically, this is a transmit command, and it will go and open the door. So much for encryption, right? So much for security, because this doesn't really work. So basically what ended up happening is this security 2.0 wasn't really encryption. It was just some special magic handshake that happened that is really easy to reverse. So as a follow-on, so I did that with an actual physical wireless Hack RF device, but the library also includes using the actual buttons. So if you guys ever used the buttons on the wall to open the door, it has wires going out of it. You could actually hook up an Arduino, hook up something to it, and control it that way. So that's what's cool about that is if you do any kind of home automation, in the past, most projects are well, just solder up a relay to that button, and it's kind of janky. It works, but now with this library, you can talk to the garage door opener, right? So you can ask it to, hey, is the door open? Is it closed? Is there a sensor tripped, right? Go turn on the light? You can also even lock it, which is kind of cool. So what does this actually mean for the current state of the garage door security? So what we found out is that this encryption stuff, garbage, it's not really encryption. So basically it's like going back in time. Yeah, it's a little more secure, but it's still vulnerable to the replays attack, just like I showed you guys in the previous slide. The other thing is, if you're a hacker and you love to mess with embedded electronics, you can fix this issue yourself. There are chips here. I linked this one from SparkFun. That is basically a little 128-bit cryptographic chip that you could add onto the garage door and your own custom remote to kind of make your door a little secure. The one thing that I recommend that it's really easy to do now is there's a lock button on your garage door opener. And then what that does is it disables the garage door opening with your remote. So it's a little safer. It gives you a little peace of mind at night or if you're going on vacation. But if it's me, just unplug the thing. If you're going to be gone for a long time, unplug it because it's not very safe. But yeah, that's my talk. Any questions?
Cool. All right. Well, thank you. That was awesome. This is very useful.
I just had a comment. Yes. I really liked your end statement where if you're going to be gone for a while, just unplug it. That's like the highest form of security. Is just
turn off all power to your house.
That's right. Awesome. Well, up next we have Brandon. Is Brandon in here? Oh, awesome. Come on up, Brandon. He's going to talk to us about write-only data code bases.
This is obscure.
That's awesome.
The lock doesn't mean
It's so funny when you introduce, like, when IoT introduces it. See, and all of a sudden your toaster does.
Yeah, no, exactly.
All right, sweet. I can't claim to be the inventor of write-only code bases. I love this term. It came from one of my coworkers, Earl, who's here today. My name is Brandon Atkinson. I'm on the MLOps team, and we think a lot about AI on the MLOps team. And one of the things that has been sort of a surprising trend is this idea of a write-only code base actually exists now. Like, you can go in, you can generate a bunch of code, you can get a working app, and no person has ever read any of that code, and you may never need to read any of that code at any point in the future. Like, it just might be done. And that's really cool, but that does come with some problems, because while some code doesn't necessarily need to be read, that can't be true for all code. Like, a lot of the code that we ship, it's actually important that we understand it. AI means that we can ship way more code, way more tokens out into production. It's easy to generate code now. And so I think that's created somewhat of an interesting dynamic, because now more than ever, a developer's ability to read code, understand code, code literacy, in my opinion, is becoming absolutely critical in a way that it hasn't necessarily been in the past. And so as I think about this problem and how to grapple with a world where we have so much code that's being generated by AI, one of the things I think that's a powerful tool in our toolkit is PRs. They already exist. We already likely have flows built around the idea of reviewing code like this, and it gives that important check where we say, hey, this code is important, this code is critical, and at least one person, but hopefully a few people on the team, know how this code works before we roll it out. A, so that we can make sure it's not going to cause an outage or a problem, but B, so if that does happen, we have some people that know what's going on and can maybe work to fix that. So I just want to talk for a second about how you get good PRs. Building a culture of good PRs on a team is absolutely critical and will pay huge dividends. It will help you reduce the amount of debt that you take on. It will help you understand what your coworkers are doing better and reduce silos. I think it's really critical. And the most important thing for me when talking about how you make sure that you have a good culture of PR reviews on your team is to separate yourself from your code. You are not the code that you write. You're going to ship bugs. You're going to do dumb stuff in code. I've done it. We've all done it. That's okay. That doesn't mean you're a bad person. It's really important to separate yourself from your code, because that allows for free criticism of code that needs to be adjusted. Makes it a lot easier to say, hey, I read through this code and I have some comments. There's some things that need to be fixed, some problems with it. Building up a culture where people understand a criticism of their code is not a criticism of them is like one of the bedrock foundations of a good PR culture on your team. Other things still apply, like small PRs are still good. You might be able to generate 1,000 lines of code really quickly, but maybe you shouldn't commit them all at once. Thinking about how your team is going to use the tools available to it to do PR reviews. What options are you going to use to do what things? What goes on Slack? What goes in comments? What PRs approve? How many PRs reviewers do you want? Those things matter. Talk about those things with your team, because establishing a good culture around that, I think, is absolutely essential. When you ship code now, I think it's more important than ever to think about how you are going to review your own code. Because again, you might not have written all of your code. It's very possible that you generated a bunch of stuff, or even a small amount of stuff. You don't necessarily know every line the way that you once did. So check out a PR in GitHub or in GitLab or wherever you look at your code, and like context switch into that UI. It's magical. Something about shifting from writing to reading will help you see your code in a different light. Comments. This is a thing that I've noticed is becoming really common. People will leave nonsensical comments that were generated by the AI that are completely unuseful. Yes, they don't affect the code, but they can affect readability. Please go back, clean up your comments. It can be really embarrassing, especially when the AI adds a to-do comment and you've missed it. It's like, hey, we should implement this. Don't give me a to-do comment that an AI built. Please read your code before you ask me to take the time to read it. Make sure you understand your code. Make sure you're running your code. Make sure you're reading through your code, because it is frustrating for me as a reviewer if I can tell that you didn't really care about the code before you asked me to care about it. Woo! Yes, 100%. As a reviewer, when you get the code, remember that you are the second line of defense if something goes wrong. Your name is on that PR if something rolls out. So ask yourself some questions. Do I understand how this code works? Do I understand the structure underlying this code? Are the CI/CD checks passing? Am I prepared if this code rolls out and it goes poorly to jump in and start helping trying to fix it? Because I'm the next most informed person on the team. And honestly, you might be the most informed person depending on the state of the PR that came to you. So it's really important. Read and understand the code. And then some quick closing thoughts. This might not apply to everything, right? Like, I want to make it clear that the one-off scripts you're writing, the throwaway code that you're doing, the data science stuff that it's just like, I wanted to build a pretty visualization and then throw stuff away. Like, you don't need to do this for every piece of code, but a lot of code is still important to review and understand. We still are finding situations where people roll out generated code and cause outages and cause problems. Like, good reviews are still worth it. And I think it's important as people who want to develop our skills and be valuable in the industry to recognize that some of the balance might be shifting. And it seems, again, to me, like the value of understanding, reading, being able to be a really good editor of code, a really good critic of code, is more valuable than ever. So if you want to be a valuable developer, maybe consider shifting more of your focus and time into being a good reader of code rather than a good writer. And that's my talk.
Awesome. All right, up next we have Hamza. Hamza?
Yeah, I'm here.
Awesome. Come on up. How do you say your name?
Hamza, yeah, you said it
Hamza.
right.
Sweet. Who's going to talk to us about red snakes? That's it, right? That's your title.
I meant the red snake for the skiing in the cottonwoods, but yeah. So red snakes. Let's go for it.
Showing anything or?
Yeah, I will.
Okay.
I don't know why I'm doing this. I feel I lost a bet. I'm just. Should I allow that?
Oh, we have access.
Perfect.
Python.
Python.
Yeah, so I wasn't planning to present. I wrote this code, which is probably the worst code I've written like 2 years ago.
Yeah.
And I'm just outing myself here. So for those who don't know, 2 years ago, a bunch of the skiing resorts in the Cottonwoods switched to having a parking reservation. We used to wake up at like 6 a.m. to get first come, first serve parking, and then they switched into like a parking reservation model, which was good on the long term, but that meant that you have to actually go to the website and reserve the parking for the week before. So I didn't want to do that. It also meant that a lot of people will like go to the website at the same time and grab and try to get to reserve parking. That also meant that a lot of people did not get parking reservations. I wanted my bot to do that for me. So I wrote this script real quickly. Like, I gave myself 2 hours to finish it, and the fastest way to do it was to just use a scraper, go in, get the HTML DOM, and like do whatever it needs to do to reserve the parking. One issue I had was that the calendar to choose the day from was embedded. So to circumvent that, is my code really small? Or should I? I'll just. not that. All right. So yeah, the calendar was embedded, so I did the worst thing possible, and I got the size of my web browser, and then I got the size of the calendar, and then for each day, like it calculated the coordinates on the page so that it goes in and presses the day off and then gets and then chooses that to like move to the next page and get that reservation, and it worked. So I just wrote a cron job that will just every week on Sunday at 3 p.m. it will go in, get me reservations for Saturday and Sunday, and I never needed to reserve ever again. I haven't used it for 2 years. Apparently, they did change their UI, so I can run it real quick just to show you what happens. But so you can see it. Whoop. Well,
Hey, it did something though.
it did something. It was working just 5 minutes ago before I came here, but it's okay. So that's what it did. I think what I wanted everyone to get out of this is, you know, sometimes you just want to like write really bad code for your side project to use it by yourself. I think we like all try to like over engineer stuff, and like it's fun, like being engineers, we would like to over engineer it, but sometimes it stops us from like actually pursuing and like doing our side projects. Just if it's gonna take an hour to do something, like just do it. Never have to get parking reservations. It's pretty dope, and I'm pretty sure a lot of us have these like small nitty stuff that would really benefit from automation that we don't do because we think it's gonna take a lot of time, but sometimes it's just real quick. So thank you.
Awesome, thank you. Next we have Josh Durantas, who's going to talk to us about chess.
Yeah, chess.
Cool. All right, guys. Hi, my name's Josh. I'm a software engineer at Vasion, and I was needing a side project to work on. I'd been in my career for a while, and I didn't want to do like a recipe database or anything like that. So I was like, let's do something I actually like. So I went with chess. I'd missed learning programming ideas from like making games. I remember the first time I made Flappy Bird, like in my Python class. I thought that was like so fun. You have to solve a lot of interesting problems, and it like builds skills that really carry over. So I wanted to do something kind of novel, but not like too novel. So chess is awesome. There's a lot you can learn from it, and Go is just the language we use at work, and I wanted more practice with it. But more specifically, like why Go? Well, when you have a chess engine, it needs to be fast, and at least compared to Python, Go is actually quite fast. There's nice byte manipulation support. There's a really enthusiastic community of people that love Go. Again, practice what I work on. I love the Go Gopher, and also I think Go's syntax, especially the if error is not nil, it's awesome. Very fun to work with. So another example, like you can do this in other language. I just like how in Go I can say a piece. Well, instead of like a struct, right? It's got all these attributes about it. A chess piece can just be a byte, right? I can have flags for what type of piece it is, whether it's black or white. A move, I don't need a move struct with a source, a destination, a target. I can just have a uint16. I can fit everything I need in 16 bits. I haven't found an application for this at work yet, but I do think it'd be very cool to have a microservice with a customer that's just 16 bits. But anyway. And then why chess, right? Well, it's so well documented. Thousands and thousands of people have studied it. I think there's millions of players these days. You can learn so much about the game. You can just learn how the moves work. You learn advanced strategies, all this other stuff. But more specifically, you can play against your own creation if you make a chess bot. So you can watch your child get better than you in real time. There's lots of algorithms you can learn. The way you have to speed it up, the methods you try, like chess has a branching factor of about 35. So in the mid game, there's about 35 different moves per state. So if your program is slow, you're gonna make like hardly any progress. Your AI is gonna be terrible. So even without making like an AI that knows chess better, you can just write better code, more optimized code, and that improves it as well. So you don't have to know chess, you can just know programming and make better chess bots. And then also, if you do multiplayer, you have protocol support, networking. You could make an online website where chess bots compete against each other, right? Go is a pretty good use case for that, and chess is awesome. And also, a lot of people think of Go as like primarily a back-end language, but there are libraries that will interface with the OS to make windows, draw objects, and I thought that would be fun to like take another look at Go as like a general language, not just a back-end language. So when you make chess, you can make the chess engine, but you can also, as a separate program entirely, make a chess GUI. And that's just an entirely different set of problems, right? Like, I need to resize my window, right? I need to load these SVGs. I need them to not look terrible. I need to respond to clicks, stuff you probably haven't done in Go. And it's just seeing new and novel problems is always good for learning. And also, you can make the chess engine itself, right? So if you don't know, a chess engine is a stateless machine. It takes a board position and returns what it thinks is the best move. You can have it stop based on how many nodes it searched or some depth or just all sorts of things. But picture here Stockfish. It's an open source chess engine. It's the best one, actually. But doing this is where you're going to learn like AI techniques like alpha beta pruning, min-max search, transposition tables, all sorts of things that are just good programming and math concepts if you want practice. And then just, again, it's just more time with the language and things you probably haven't done before, but might come up somewhere else. Anyway, that's about it. I just think chess is a fun side project if you're ever looking for something. I'm doing it myself. I haven't posted anything to it in like 2 or 3 months, but I will get back to it. And yeah, I can do a live demo real fast. Nothing too fancy. But I've got chess. And it works. No illegal moves, all the stuff.
Awesome. Thank you, Josh. That was fantastic. All right, and then our last lightning talk is going to be Jonathan, who you will also hear again later, but he's going to give a short lightning talk as a teaser, I guess, for his speaking.
Oh, wait. Yes.
I thought I just did.
I just paid attention.
Yeah, that would be.
I promise it does other things too. Weird. No, the HDMI works. It does weird stuff with USB-C because it's a whole hub connected.
Yeah,
so it's often a lot weirder than just the screen.
All right, that's good.
Yes.
All right, while I'm figuring this out, quick pop quiz. I think I'll figure that part out. Oh, yeah. Testing, okay. Pop quiz. I like to do this when I learn new things about Go. I ask other people if they know the same thing. What is the smallest package in the standard library? This is inspired by the way, this lightning talk is inspired by a conversation we had at Starbucks this morning.
That's why I'm not getting the answer.
You don't know the answer.
I don't.
I don't think you do.
Is it HTML?
No.
It's 2 functions.
That's not even HTML in the standard library.
Yes, has 2 functions.
What, is that the full package path?
Full package, yeah.
But no, that's not the smallest.
Okay.
I might have overlooked that one, but it's not the smallest.
We're doing this by lines of code, by functions, by what?
Recorded artifacts.
Public space.
So yeah, two in HTML, two files. Okay, you're right. Hang on, let me fix that first.
Why do you know that?
Why wouldn't I? If you use it to talk on networking stuff. Well, a little copy is better than a little return. So I thought I'd just copy the statement also. That's all package.
Still end up copying.
No. The XHTML. There's template HTML. There's multiple HTML packages. There's 3 of them. There we go.
Yeah, we're good now.
I can't see what I'm doing now.
What? You did 2 screens?
You can look at the back.
Okay, so HTML has two exported functions. That's what we're looking at right here. But no, there's one that has even fewer than that. Time/tz data has 0 exported symbols. It's only useful in import, but that's not what I'm talking about today. What I'm talking about is the CMP package. I should have done this differently. I'm going to try to mirror my screen so I can see here too.
It'll make your talk easier later.
Better to do it now than do the real talk, right?
Yeah.
Now back in when you're ready.
Not detecting the other girl.
Ooh.
You do that, and that's what X wants you to do. They basically you make them the same geometry.
Okay, so what I actually want to talk about isn't that. So TZ data, just for reference, 0 exported anything. It's only useful as a blank import, if that makes sense. Okay, but we were talking about ba-da-bum-ba-bum. You don't need to see my errors. Where did the window go? Sneak preview, don't look at that one. Okay, CMP. So CMP only has 4 exported symbols. We were talking about with Carson earlier today that at the meetup here, the Go meetup, which I'm sure many of you attend, they're doing the standard library, and I was like, are you going to do a talk about CMP? Because it's so short, it's going to be a quick talk. So here it is, here's that talk. The CMP package, you probably only ever need to use one symbol from it, and that's the OR function. Has anybody used cmp.or? A few people? Hopefully by the end of this talk, you'll all start using it, because it's really useful. And to demonstrate how it's useful, actually before I do that, let me talk about the other ones. Ordered, it's just a type that defines types that can be ordered, the built-in types that can be ordered in Go. You never need to use this directly, but I guess it's useful to know it's there. And then less and compare. Compare, you pass in 2 ordered values of the same type, 2 integers for example, and it will return either -1, 0, or +1, depending on whether the first argument is less than, equal to, or greater than the second argument. And less does what it says on the tin. It returns true if the second argument is less than the first argument. But OR is fun. OR is the one that you probably should be using. To demonstrate, I wrote this little program in the Go playground. So the idea here, below the dashed comment line is where the interesting stuff happens. If you've ever done this, cmp.org is going to be your friend from now on. So you have an input. Maybe it comes from a REST API, maybe it's user input, whatever. And you want to default to something if it's not set. So in this case, my input is just var input int, so it's the 0 value, which is 0. And then on line 13, you can say, or you can see that I set number equals input. On line 13, if number is 0, so it hasn't been set, then I set number equals the default value. And I've defined on line 9 the default value is 50 in this case. And then I print the final result, and you can see at the very bottom of the screen, the number is 50. CMP-OR makes this ever so slightly nicer. Live coding is awesome.
Oh yeah. It is.
And now there's the exact same output. CMP.OR takes any number of arguments from 0 up to however many is a variadic function. So you can pass it 2 or 3 or 12 or whatever. And it returns the first one that is not the 0 value. That's it. That's the standard library CMP package.
Thank you, Jonathan. Sweet. Well, up next we have William. While he's setting up, you could come up and set up. While he's getting ready, now that we've seen someone struggle with Linux, I'm interested in what the OSs we are using here. So if you're on Windows, raise your hand. Not by choice. And if you're on Mac, raise your hand.
Yeah.
All right. And if you're Jonathan and Carson and anyone else on Linux, we got a few. Okay. We got a few. It's actually more evenly split than I expected.
Windows is the question now.
Yeah, now that's a good question. All right, let's go back. Windows, raise your hand again.
This is daily driver laptop. Now.
There is more Linux than Windows.
WSL for daily driver? My job forces me to use Windows. I don't like it.
Yeah, well, that's what you get put under.
Man, no one's
Awesome. Well, I will hand it off here to Will, who's going to teach us and talk to us about data streams. So thank you.
All right, so good afternoon, everyone. My name is William Hill. Formerly of a company called Moroxa that helped create this tool. So I'm currently fun employed before I start my next gig. So enjoying a little bit of a much needed break in sabbatical. But first time here in Utah, very excited to be here. So thank you for the organizers for allowing me to be here. And I'm going to talk a little bit about Conduit. So it is a real-time tool built top to bottom in Go for streaming data. So I'll try to, I know we only have 30 minutes, so I'll try to move through the slides pretty quickly so we can look at a little bit of like a code and actually look at a pipeline. So real-time data, like data is all around us, right? And we're constantly generated, whether it's us as individuals or as larger corporations or companies. And it's coming faster than ever. So a lot of times we need to be able to operationalize that data, right? So as it's coming faster and faster, how can we get better and better insights out of it quicker and quicker? So that's what we try to accomplish with Conduit. So with traditional ETL models, mostly done in a batch format, it has its place, right? Certain things you don't necessarily need in real time, that you can kind of, batch it, process it and as it comes in, or whether it's hourly, daily, monthly, whatever. Don't always need real-time data. But in some use cases you do, right? But with the batch method, sometimes you can run into operational overhead, right? So dealing with job schedules, workflow managers, dealing with just the overall architecture can sometimes be laborious. But it also then can lead to stale insights. So if you're doing something where you're generating, constant data, where you think about whether it's stock market data, I'm a big sports guy, where you're trying to do like sports analytics, like doing like play-by-play data and doing like win probability. That data is coming in constantly and coming in fast. So you need to be able to just be able to capture that data in real time and be able to process it. So, oh, sorry. So you need to be able to operationalize that data quickly. And sometimes batch just doesn't cut it. So how can we start to, think about doing this in real time while also trying to reduce the operational overhead? So this is where Conduit comes in. So this is the impetus behind building this tool. So it is a lightweight open source Go-based streaming tool It compiles down to a single binary, so you can deploy it even on edge devices. And you simply just need to define a source and a destination using a YAML file, and you can start to get real-time streaming data. So we're gonna, again, I know I'm moving kind of quickly, but we're gonna kind of go through and look at a little bit of the internals of like using Go, why they allow Conduit to be, and then look at some examples. So why use Conduit? So some of the things we already talked about, right? Where it's ideal for developers who are trying to build real-time data streaming solutions without a ton of overhead. So you can look at applications where it's like, replicating the database, so moving data from one database to another, or just any type of like event-driven architecture. Conduit is a fairly good choice for that. So it provides it comes with certain connectors already built in, but we also provided a SDK where you can then build it, custom connectors for your own data sources. So the value to different stakeholders. So we talked a little bit already the value of like for engineers, so to be able to quickly build data pipelines, but you can think about just from the business aspect as well. So you have faster time to market to try to get operational data insights. With the DevOps team, it combines down to a single binary, so hopefully you can have easier deployments and maintenance with that. And then with product managers, you can enable real-time feature and user experiences. So a brief look at at Conduit's architecture. So Go's internals around concurrency is part of what allowed Conduit to come to life. So using Go routines is like part of the bread and butter to Conduit's internals. And admittedly, I'll say before I came to Morox, I had never used Go before. So I basically learned Go on the fly, and it was a very, very interesting experience, and I really enjoy using it now. By no means an expert, but I was able to learn a lot, and in particular around like its concurrency model. So it uses the Go routine, so the really, really lightweight concurrency, and then to communicate between the Go routines, we have channels. So this allowed Conduit to be able to really operate very efficiently and operate at scale. So to talk a little bit about Conduit's plugin architecture. As I mentioned, the architecture has some built-in plugins, so some common data sources that you may deal with. So Kafka, Postgres, S3, those are included, batteries included out the box whenever you download the Conduit binary. But we also have the SDK where you can then go and write your own connectors. So we'll have some examples as we move forward in the slides of some connectors that I wrote for different projects that I worked on. That we didn't support natively, but then we were able to, roll those out. And I think the list is currently over like 100 supported data sources out there, and more constantly being added. So I have there written that you can write them in any language. We pretty much always defaulted to writing the connectors in Go. It was just the easiest thing. All of our rest of our data stack was primary, or stack, with Conduit was primarily written in Go, whether it was using the connectors. And I actually haven't mentioned the processors yet either. So the connectors can be both source and destination connectors, but also our processors. We have the processor SDK written in Go as well, which can actually operate and transform data in real time as it's moving through the data pipeline. So I have a couple links here, and I'll be sure to share those out as well, as far as the Conduit SDK for being able to go and look that up. We also have templates as well that you can quickly clone for building connectors or processors. So just around the push model. So as you build the connector, you can connect to whatever data source you have there. And it's going to, depending on how you build your connector, it's going to constantly, whether it's going to be polling or just connecting to like a WebSocket or something like that. Anytime that source emits a new record, it will then come through the pipeline. If you have a processor there, it can optionally process that data and then move it to 1 to n number of destinations. So we also built around Conduit like some observability, so that you can actually hook in and look at the state of the pipeline and see the data as it's flowing through. Sorry, part of that got cut off. Again, I know I'm blowing through this pretty quickly. And also one of the things we really wanted to try to, which I really appreciated about Conduit, like one, it is open source, so it's out there for anybody to use and contribute to. Also, like really wanted to have a clean developer experience, because if there's too much friction in using it, especially an open source product, no one's going to use it, right? So we really wanted to value the developer experience of being able to quickly create pipelines, stand them up, and get value out of them. So as I mentioned, it compiles down to a single binary, has a clean CLI, and a single command of just saying conduit run to start to spin up your pipelines. So the configuration files are written in YAML, which we'll see an example of that momentarily. And and there's some niceties around it, having both REST and a REST API and gRPC to be able to connect to your pipelines for programmatic control. So just a little bit about the something's cut off. Okay, I'll scroll back. Around the performance and reliability. So again, we designed it with scalability in mind, also with reliability in mind. So each record has an acknowledgement as it comes through the pipeline to try to only have each record delivered once. And then we also have fault tolerance built in. So we have like a dead letter queue for any times like a record needs to be dropped or retried or something like that. And one of the nice things too that we get basically out the box just with Go's concurrency model is natural back pressure management. So anytime like those channels start to block, the buffers fill, it queues them up until they're processed. And I know this may be hard to read, but there was also another open source tool called Benchy that we wrote and used to get some benchmarks. And the throughput, I think at our highest, or one of the things that we measured was like 569,000 messages per second. So these are a couple of use cases, again, that used in production. Some of these I worked on personally. One was the hotels network. So being able to integrate their sales and support. So they wanted a streamline of data from moving from Salesforce to Red Panda. So we were able to build more custom solutions for them. One that I worked on personally was a healthcare project where, as we talked about, in batch, sometimes it works and sometimes it doesn't. In this case, there was a healthcare provider who was getting data that was just sitting on an SFTP server, and then it wasn't being moved over into like a patient came and saw their PCP, and that data needed to go out to a specialist. It could be anywhere from 2 to 5 days before that batch job ran to move that data out to those specialists. So we ended up writing a custom connector and processor to process HL7 data, which is a healthcare format, to move that data in real time. So as soon as the data hit the server, anytime if it needed to go out to any other provider, it could happen immediately. Another one I personally worked on was in a military space, where this was dealing with AIS data, so maritime data. So AIS stands for Automated Identification System. So this was getting real-time data off of ships that was in transit. So being able to, again, it's one of those things if you were doing in a batch thing, and it's not necessarily as useful, right? Because if they're constantly moving, they could change course due to any number of factors. So in this case, we were getting the real-time data from a GraphQL API, and then pushing that to the Unified Data Library, which is a data lake managed by the Space Force. And then lastly, another example is Spill. So again, we can see this was used across several different type of industries and use cases. So Spill is a social media app similar to like X or Blue Sky or something like that. And they were tracking real-time user engagement and moving data from DynamoDB to Postgres. So we were able to use Conduit to manage that as well. So I know I've talked a lot, went very quickly over these slides. So now we can actually jump into a code editor and actually see Conduit in action. Is that large enough? Do I need to make the text? All right, I will make the text larger.
That's good.
Switching to light mode also makes it much more readable in projection.
But then you'd have to be in light mode.
I was trying to find the settings if I can do that quickly. I don't know where that is.
Yeah, that's what I'm just, it's, yeah.
Don't worry about it.
All right, cool.
A setting for that.
Not that important, just slightly better.
Gotcha. Okay, so this is a very contrived example. Let me put that out there up front, where we're going to look at based on an anomaly detection pipeline. So what I first have here is just a very simple, fast API server that's just generating just some mock kind of like data of things coming on that's going to basically going to flag like security issues or something. So very contrived. Just a little simple example to move data, just to give us an endpoint to source some data from. So then I have just a basic, just a Postgres database running here in Docker. This is where we're gonna push the data to. And then as we start to get into actually using Conduit, let me close this to move that and get more space. This is a YAML file to define a Conduit pipeline. So in this case, we have the pipeline ID, which is anomaly detection, give it a status, and then we can start to define the connectors. So in this case, I'm defining a source connector that's using the HTTP source just to connect to that Postgres database, the fast API server that I have running. And then from there, I'm defining two destinations. The two destinations are actually going to the same destination. They're both going to the Postgres database, but they're going to two different tables. So one, it's almost a facsimile of like a medallion pattern, where in this case, we're moving the raw data to one table, and then we're gonna do some transformations on the data and move that to a separate table. So to be able to keep the raw data, but then also some operationalized data. So in this case, the first one, we are moving that to the raw security table. So this is just going to take straight the data that we're getting, that we're sourcing from that fast API server and moving it wholesale, no changes for the most part. Well, I'm doing a slight change where I'm just generating a random ID, but moving that data over raw to a table. The second destination connector we're using, again, going to that same database, but a different table. And what we're using is one of our AI processors. So we're using our OpenAI text gen processor. So what that is, I have an OpenAI API key, and I have a system prompt that as this data is flowing through the pipeline, I'll be able to send that off to OpenAI, do some processing on it, send that, and whatever the API responds back to, get that, and then put that into the database in a given format. So in the system prompt, we tell like OpenAI, we want the format, the data in this particular format. And in this case, we're just doing a simple analysis on, say, if it triggered and this was flagged as some type of anomaly, say, hey, what are some remediation steps that we could potentially do with this? So again, a bit of a contrived example, but just showing how we can, move data in its raw form and then move data that's been processed in flight. And then also define this dead letter queue for any type of errors that happen along the way in the data processing. So I'm gonna mic down just so I can type with both hands. We can simply say conduit run. But first, I actually showed I have the database running in dbeaver, and we can see the database truncated tables. I truncated the tables, so there's nothing there right now. So if we do conduit run, again, this is a single binary that I'm on a Mac, so you can install it via Homebrew. If we go here, this is first the raw table. So we can start to see data coming in. And again, like I said, very contrived data in this case, where we can just see like, hey, this was flagged as a security threat, the threat type, threat level, associated CVE, so on and so forth. But if we go to the AI analyzed data, we can start to see a little bit more insight because this data was passed along and processed by LLM before we put into the database, And it can say, okay, what are the affected systems? What's the potential damage? What are the immediate actions that we should do to try to respond to this incident? So if you have like a run book or something like that, you know, hey, what should we do? Should we conduct a forensic analysis, so on and so forth? And then we also have this mitigation strategy. So again, you may not necessarily do this because you may not want to say anything like your security issues to a LLM. That probably wouldn't be the best idea. But like I said, this is just a contrived example to show how quickly you can create a data pipeline and also get production or like operational insights out of it. So again, I know I'm moving very quickly because I know we only have 30 minutes. So and then last, I just want to talk about, again, this is open source. So out there on GitHub under the Apache license, you know, if it piques your interest, feel free to, you know, go out there, toy with it, play around, contribute. We would love to have contributors. You know, again, handling open source projects is a labor of love. So hopefully this could be of value to the community out there. We know, like I said, we personally love Go. Go has been awesome to work with. It's been a really fun journey for me to learn and continue to learn about Go. It's one of the reasons I was really happy to be able to come here. But yeah, it does some cool things now, but it always can be better. So key takeaways we wanted to say is just we try to strive for simplicity with, you know, without compromise. So still being able to create powerful data pipelines, but without the overhead of like dealing with the JVM or no offense to Java people out there, but like anything that's, you know, all other overhead that could come with some of the other tools that's already out there in the market. And then just goals, just the architecture and concurrency model of Go really allowed Conduit to be what it is and flourish. And we wanted to try to put a tool out there that would allow any and everyone to be able to leverage real-time data. And that's pretty much all I have. Yeah, happy to answer any questions to the best of my ability.
What's the overhead for writing a custom processor or data source? Like, what kind of implementation? What does it take to do that?
Yeah, so again, we have an SDK for that, and we also provided like a template that you can clone to kind of get you really started. It gets you most of the way there. There's a couple patterns that we kind of developed along the way. Like one was like an iterative pattern that we put documentation out there around. We started toying around at one point with like code generation, trying to, you know, where you can just prompt it and it generate a connector for you. Didn't really get to the point where we wanted it to. But there's again, all the connectors out there are open source, so you can kind of look and model and pattern off of those. But the definitely recommended way is to go and clone a template because it gives you really all the methods that you need to define. And yeah.
So it's like implementing an interface or a gRPC server or something like that?
Mostly just implementing an interface.
Okay, that's easy. Do you have to build that into the conduit binary, or will it execute it for you?
Yes, you don't have to build it into the binary. So whenever you're running it, it's gonna, and you can, there's flags for these, but by default, it's gonna look for a couple different directories. It's gonna, whenever you're running it, it's gonna look for like a connectors directory. So if you build like a custom connector, you just drop it in there, and it'll look and load it at runtime. Same thing for processors. You drop those into that processor directory, but you also, with the flag, I think it's like -- connectors path or something like that. So if it's not in a directory called connectors, you can define where it is, and it'll detect those at runtime.
If you know the answer, how does this compare and contrast to Benthos?
I don't have a good answer for it. Like, I'm not as familiar with Benthos, so I can't really, I wouldn't be able to give a good answer that I'm confident in.
Thanks.
Yes.
One of the slides mentioned a stream inspector over WebSockets.
Could you repeat? I'm sorry.
One of your slides mentioned you could inspect the pipeline over WebSockets.
Mhm.
I was curious if you could show that, or
Oh shoot. I can. I don't remember how to do it off the top of my head. Put me on the spot. Let's see. Let's see if I can figure it out. If I can't figure it out right now, which highly unlikely, I have to go and like comb through the docs myself. I'll give it a try. But if not, I can try to somehow get that information to you later.
Yeah.
Oh, I saw another hand.
Thank you.
Yep.
Awesome. Well, next up, we are getting to hear from Logan about Go channels. And hopefully it's not too much of a mystery, but we're going to learn a lot about them right now.
Is this already on? Okay, great. Let's address the elephant in the room. It's 2:30 in the afternoon. You've had lunch. You've gone through 4 other sessions. Let's all take a moment and recognize we're all falling asleep right now. That's okay. This is a great talk to fall asleep through. Great one here. If I can get a sense of my audience, I would like to, I'm gonna, please humor me. I know we're engineers. We don't want to play games. I'm gonna ask you to play a quick game with me, if we can. By raise of hand, when it comes to channels, not routines, not functions, when it comes to channels in particular, if you feel like you are a master guru of channels, I'd like you to raise your hand at this point. I got a couple of brave ones, okay, we're good. If you feel like if you were asked to talk about channels in an interview and that would cause a mild panic attack for you, you can raise your hand. Okay, we're doing good. Now, lastly, if you are here at this conference and you've never heard of the word channels before this talk, can you please raise your hand? Great, not television channels, by the way. We're at Go channels. Great. We're gonna hopefully, for those who are gurus, I'm sorry. It's going to be an okay talk at the end of the day. For those who are in that in-between phase, just know that those gurus are making you do their work at the end of the day. So for the gurus, you knowing this makes it easier for them to write your unit tests. But for everyone else, this is just for you to get some more information on channels here. I'm so sorry for the camera guy. I will promise not to wander. Okay, I've already got a thumbs up. He's okay, great, because I'm a wanderer. I apologize. We're going to talk a little bit. I happen to have the benefit. I finished a master's degree in computer science, which some of you feel like is probably a waste of my money and time, but I did. In particular, a lot of my emphasis was on computer science education, which is even more of a waste of time and money. But I happen to work underneath a professor by the name of John Edwards, and he developed a program referred to as Fanon. That is programming Hanon concepts. Hanon is a piano concept. If you ever did piano and you had to do keys and you had this Hanon book, that was a concept that he took into programming. And in his major studies, he broke down the idea of when he teaches programming, we would separate programming language syntax from computational logic. Those are 2 separate core elements of education. To explain what I mean by that, you may all notice this kind of looks like a function, but it's missing something. Let's play another game. What is this function missing? Parentheses, thank you. I love that. We're all playing Dora the Explorer right now. Don't worry. Okay, we got another one. What is this one missing? It's missing a curly brace or a bracket or however you guys want to call it in this case. This one is missing its brother right there. It's missing the bottom one. What is this one missing? This one's a little trickier.
Test.
I heard 7 different ways of referring to the keyword func. Good job. You all got it there. Now this one, what are we all going to call this?
Identify.
The identifier, they technically refer to this as the alias. That is the alias of the function here. Absolutely. The way Fanon worked is you would do 100 exercises like this. Write a function from scratch. What is missing? What is that? And you drill into these students the syntax of how to write a function. And then, after all that is done, you come to class and you learn conceptual logic. What is reusability? What is parameterization? What is encapsulation, cohesion, abstraction, modularity? All of that wonderful Gang of Four stuff that we pretend as Go engineers doesn't exist. Because to reference Gang of Four means that Java exists as a language. If you don't know what the Gang of Four is, raise your hand. Okay, I officially feel old, and I come from the Java world, I'm sorry. At least I came to Java before I went to Go. We are gonna talk a little about programming language versus computational logic. Realistically, programming language syntax is how to write an application. Computational logic is when to use a particular tool versus a different tool at the end of the day. I firmly believe whenever you have been taught channels in the past, it is only ever focused on syntax. It's all the syntactic sugar in the world. How to do an unbuffered channel, how to do a buffered channel, how to do a read-only channel, how to do a write-only channel. And no one in their right mind would ever tell you why, or when, or what is the purpose of this, or what is the purpose of that. My talk will cover zero syntax. We are only talking computational logic, so that by the end of this talk, you know when to use a channel and when not to use a channel. And if you know those core concepts, guess what? You can talk to everyone else on their AI tools, and they'll tell you how to do the syntax. Or Google, or this old thing called Stack Overflow. May it rest in peace. We're gonna cover 3 concepts: asynchronous writes, asynchronous reads, and asynchronous reads and writes. Now you might think that's redundant, and it's not. So we're good. We're gonna talk about what is a write. So let's go into core functional logical concepts here. In channel logic, a write is whenever a system publishes data to a queue. So realistically, I've got a channel, I'm getting data written into it. However, let's broaden the context of a write to be everything the system does before it gets to a channel. It's all this different logic here. So think of it as let's write it this way. So I've got a write, I've got action A, which leads to action B, which leads to action C, leads to action G, and that results in a write to a channel queue. Now I'm calling this a something because we're gonna get into some more details about that, but let's just consider all of this concept. These are a write, all combined together, resulting into a write to a queue. So what is a read? Well, a read is when the system takes data off the channel. But let's broaden that concept too to everything that happens after the data comes off the channel. So, we've done all the write actions, they've led to the queue being published to, and now we're doing action W, action X, action Y, and action Z. Now, some of you have studied a lot. And this might look like a pattern you are familiar with in the past. It is called event-driven architecture. It is the process of something, a write, also known as a publisher, leads to the processing of a queue, and then a read is a subscriber pulling data off of that queue. That something is our event queue. Now, this is a hard question. Who in this room has never at all worked with a queue beforehand? Okay, great. We're in good hands. Who's worked with SQS, SNS, all of that stuff before? Okay, how about Kafka?
Yeah, let's talk.
Okay, what about Kinesis? Who's worked at all with that? Okay, let's think. What are some of those? RabbitMQ. Okay. What are some of the other bespoke ones you all love that I don't know about?
Gnats.
I'm sorry, what? Gnats?
Jetstream.
Gnats?
Yes.
Like NATS?
Yes.
Okay, great. I feel really ignorant. That's great. What else have we got that I missed?
Coral.
Whoa, I really need a microphone. One at a time, please. Loud.
Async.
Async. Okay, what else?
NSQ.
NSQ. Okay.
Temporal.
Temporal. I heard one over here.
Redis streams.
Redis streams. We've all worked with queues, right? Channels are just in-memory queues. That's it. Talk done. You now understand channels. That's it. Thank you. Yeah, then right there. We'll go a little more detail. That's all they are. And all this other like read, write, buffered, unbuffered, it's all syntactic sugar to get the queue to do specifically what you want. But as long as you keep in mind, these are just in-memory queues, the complexity goes out the window. Now, I want to demonstrate some channel logic in a code, maybe show you a couple of things you never knew you could do with channels, and I want to do one important thing. I want you to take the idea of a routine, and I want you to throw it out the window. Channels can exist without routines. They are things that are independent. Do they work with each other? Yes. Do you ever think to use a channel without a routine? Probably never. At the end of the day, but it's the same way of like, we treat queues as this, like we have, like you guys all defended gnats, like I was an idiot. And this is a queue, but like, if I told you gnats could exist without a Go server, well, you're like, duh, of course, it's a queue. Channels can exist without routines. They just serve the routines. They serve the service at that point. So we're gonna build a system called, we're gonna basically create an in-Go version of SED. I want you to all do me a favor, and if you've ever heard of the program, the CLI tool SED, please raise your hand. Okay, everyone who has not, please raise your hand. You've never been a DevOps engineer, and I'm sorry. That's just life. SED stands for Stream Editor. The main thing you're ever gonna use it for is most likely search and replace. You literally type in a command that's like SED, and you hand it a regex string that you copied off of Stack Overflow. Or you used whatever AI tool you're all using to have it generate for you, and it will do a search and replace for you. By the way, if you have not noticed at this point, I do not use the AI for hardly anything. I'm a fundamentalist by nature. I train way too many engineers on these fundamentalists to ever want to trust AI to do this for me, because I just feel like people should know this crap. We're engineers. That is the point of engineering at the end of the day. So, but if you're all AI focused, that's totally fine. You can all silently judge me or loudly judge me, however you feel like. We're gonna build a synchronous system. Now, I'm gonna show the basics of this system. There's a bunch of like little fluff to make it easier. I have built a struct here. I almost called this a class, and I almost got persecuted for that. I have a struct here that is basically just a struct to gather arguments off of the CLI, and then I have this idea of a file action. A file action, in this case, if you notice, it has 4 elements. We have a directory, a find, replace, and a name. This is the idea of our event that is going to be occurring within the process. And then I have a read function, a write function, and a main. And we're just gonna briefly look at main here, pretty straightforward. Is this big enough for everybody? Is lighting okay? Can everyone read this pretty well? Okay, good. Within our process here, we're basically just doing a basic log to put out our arguments. I am making a buffered channel. Almost all these are gonna be buffered channels. It doesn't matter at this point. Just think of this as a queue with a maximum capacity of 300,000 items, which is a massive channel, by the way. I'm just gonna let you know that. We're gonna write everything, and then we're reading everything, and then we're running with it. So that's all main is doing. Let's talk about what this write is accomplishing. So this is pretty straightforward. SED, the way you can do it on an individual file, but you can also do it on a directory. So you will notice if you read this, this is recursive logic. I'm so sorry. That's just how it is when you're going through directories. What this does is it basically says read a directory. If for all the files in said directory, if it's a directory, go read the next level of directory sort of thing. If it's not, dump a file action on the queue. It basically says I found a file, there's a file action needed. This doesn't even know what the file action is. That's been handed down to it. It just knows, hey, I'm gonna be doing some sort of file action. Actually, it's not handed down to it, it's generated. But it effectively, in this case, let's abstract file action just being some sort of event. In this case, it's search and replace, it could be other things. So if it's a file, dump it on the queue. If it's a directory, go on down. If you notice here at the very top, every time it starts, it prints out a D. That's really fun for our logging, where it's gonna be like, if it's a D, we found a directory. If it's a period later on, we know we found a file. So that's all write is doing. Write is doing the pre-processing. It's all these actions that lead to a queue event. When we go to read is basically the exact opposite. Read is saying, go to the queue, read off the data, and do a read with it. All we're doing right now on a read would be a period. We could do a search replace on that individual file, but the idea is we don't care what happens before we get to the queue. We don't care what happens after we get to the queue. We're just focused on that stinking channel, which, as we all know now, is a queue. It's a queue. That's it. So, in this case, we're doing this all synchronous. By the way, don't know if you know this, you can make a channel, write to it, read from it, and never do a single asynchronous process whatsoever. In this case, you will have noticed, write is just a recursive algorithm going down into the files in the directories. Read waits for the writes to be done. That's why we're closing the channel right here. By the way, if you ever do this synchronously, you must close the channel before you read from it. Does anyone know why?
Blocking.
Because it will block. It will get to this read, and you're doing a loop over everything, and it's gonna be like, great, there's no more data. What do I do? This will stop the system. So if you're gonna do this synchronously, you have to say, hey, channel, you're not receiving any more data. That's all a close is doing, is just saying, hey, queue, you can't get any more data. You're done. But the data that's already in it stays there. You're not closing the memory. You're not closing it. You're just saying it is no longer writable to said queue, but you can still read from it. Does that make sense? So I create the channel, write everything, do it, close it, and then read it. So what does this look like? If you remember right, we said earlier, all of the Ds are directories, and all of the periods are files. So naturally, we get this world where we get a bunch of, it's so many directories, I didn't even see it, but you guys all saw the Ds fly by, and now we've got a bunch of periods. So that is a synchronous version of using a channel, not using a single routine, just purely channels at the end of the day. So let's talk about the first example. Would we ever really use a synchronous channel? No, it doesn't make any sense. You could do this in way more effective ways at the end of the day. The benefit of a channel is asynchronous nature. Now, I happen to, like I said earlier, to have come from, I started my prima lingua is JavaScript. I know, so hard. Yep, we got a little JavaScript user there. My second language was PHP, which I immediately abandoned. And my third language was Java. Now, if any of you have ever worked with a thread executor, debate on whether it's executor or executor or whatever, it's not a Pokemon. If you ever had to use with an asynchronous queue in Java, like an asynchronous like array, it is misery. Genuine misery. That was like a full-time job of my life for a month. Like that's all I did. It was the worst. And so like the fact that we can just write this channel and write through this whole process, one of the main things of what you would do with the channel is what I refer to as an asynchronous write. We've seen a synchronous write and a synchronous read, but now we can do an asynchronous write where we spin off a Go routine to write to our queue, but we're still doing synchronous logic to read from it at the end of the day. So we go back to here, we go to our async write. all of our files are practically the same. The major difference is, if we look at main.go, let me pull this down, is that we start a wait group. Now, we're not discussing wait groups today, we're just discussing channels. Just know that wait groups are, I don't even know how to describe it, like the redheaded sibling of channels. Like, you need it, it's part of the family, but like, you don't really want to talk about them at the end of the day. So in this case, we create a channel, we create a wait group, and we start our asynchronous writer. This is still recursively going through our directory here, but what it does is that every time it gets to a subdirectory, it starts another channel. And then it can just go through everything. So you're no longer synchronously going through the whole file process and putting it all in. However, right now, we are still waiting for that writer, those asynchronous writers, to finish. We wait for the wait group to say they're done. We close the channel, can no longer receive any more writes, and we start reading it synchronously. That code is the exact same. So in the same way we had before, and if I come up here, and I now have to cd over to our async write, we run the same command. We're still going to get a bunch of directories first and then our files, because the writing process was async, but the reading was still synchronous. So let's ask a stupid question. Why would I do this? Why would we write to a channel asynchronously and then read from it synchronously? I've got a bunch of examples I can give, but I want to hear from all of you guys first. What examples can you contrive why you would write asynchronously a channel but only read it synchronously? Any thoughts? Carson, yeah.
What if you had like data gathering that took a long time, processing was fast?
Yes, data gathering took a long time, but processing was fast, yes.
You have a singleton pattern where you only want one thing to do the action.
Yep, singleton pattern. So like one thing to actually do the action, but a whole bunch of stuff to aggregate that in terms of processing. Any other thoughts? Yeah, I got one in the back.
You don't need to lock the writes.
Yes. Okay. What do you mean by that? Keep going.
Well, if I have a bunch of memory, I could like async read that pretty easily on anything. But writing, now I've got to like mutex and stuff. And
Yes, absolutely, 100%. I think a bunch of the things I put in here are, hey, I've got a database ETL, and like I am doing a bunch of upserts or updates. I don't want to keep track of collisions. I just want one connection to the database, and maybe I've got 1 million records, but they're all in updates. And so like they're gonna go fast, they're gonna be okay, but I don't want to have collision situation. There also is a world of like, how many of you have a problem where you get too many connections to your database? Like, who's ever had that problem? I certainly have. Like, so you want only one database connection, so that means post queue, I want to make sure I'm only doing one. There's also worlds of like in-memory modification. If I'm mutexing a bunch of files, I don't want them all occurring at the same time. Maybe there's gonna be a collision. Maybe there's transactional processing. Maybe I want to make sure all of my changes occur in one big batch group. And if they all don't occur, I don't want any of them to occur, sort of thing. There's also processing time. Maybe my read off of the queue is trivial. It's whatever, it's what Carson talked about. It's like, it's very minimal, but getting the data takes a while. So I want to batch async that. So we've talked about now asynchronous writing. Let's look at asynchronous reading. This is the exact opposite at the end of the day. So I have an async read. Main looks very simple. So in this case, which this is really odd, if I am going to do an asynchronous reader, I must do that process before I start my writing. Because what's going to happen is it's going to like, if you start your writing and do all that and then do your reading, well, you're still essentially running synchronously because you've done all of your writes in a synchronous fashion. And then your reader's like, you start it and it's like, well, great, fine, but I'm going to still run asynchronously here. So you start your wait group, you tell it, hey, go read off of this queue asynchronously. I don't care what you're doing. I've got in this case, I do have a buffered channel because I don't want to kill my system. And then I start my writes in a synchronous fashion at this point. So as you all might guess, once I start this, our writes and even though our writes are synchronous, the reads are going to be asynchronously, meaning we're going to see dots and periods running at the same time, because as I write to the queue, it's going to be reading it at the exact same time. So let's see if I can CD again with one hand. And this is my async read. So we're getting all those at the same time as they're coming off the channel. Once again, let's ask the question, why would I do this? Why would I want to read asynchronously off a channel, but write to it synchronously? What are your guys' thoughts? Got a hand, yes.
So we wanted, so it can be used when we want to run and read and write concurrently, but not too much concurrency.
Yes, this is a main one. Maybe you've only got, you're on an older machine, you got 8 gigs of RAM sort of thing, and you want to make the reading process like as concurrent as possible, but I really want to save all that CPU power for that process. I saw a hand here and then a hand here.
Memory efficiency, yeah.
Memory efficiency, love it, yeah.
It's a web crawler, and you need to be really careful about how much you hit the website.
Oh, I love that. I don't know if you heard that. He said a web crawler. Like maybe the website has a DDoS or it has a limit or whatnot. And so I want to read carefully, but I can do whatever I want with it as fast as I want at the end of the day. Yeah. I had a bunch of these. Maybe you have a database ETL. So like as database ETL, you've got a bunch of CSV records to be inserted, but it's all in one big file. You're not concerned about insert collisions, yes?
We have to define ETL for everyone. Not everybody knows.
Who doesn't know what an ETL is? Okay. Thank you. I appreciate it. ETL is an old-timey word for extract, transform, and load. It refers to the idea of I get data from one place, bring it over to here, and then bring it to someone else. We now modernly refer to this as a data engineering pipeline or things like that. I still lived in the days where I literally just write one application to just like grab a bunch of data, put it on my local computer, and then dump it somewhere else sort of thing. Which is not great, by the way. Don't do that.
Don't do that.
Ever. Again. Maybe you have this world of like, I want to do that. Maybe I'm doing processing time. My write times are trivial, but my read times take hours sort of thing. Maybe you have computational limitations. You guys called all this out. Okay, last of all, we've seen asynchronous reads, we've seen asynchronous writes. Let's do them together. So in this case, we have async both. This one, pretty straightforward. It can get pretty easy to get lost in the weight groups here. I have 2 weight groups. One is a read weight group, one is a write weight group. That is harder to say than it should be. In this case, I've gotten my arguments. You can do this without weight groups. This was just easier for this presentation to do it in this way. In this case, you start the reader, same way as we did beforehand, add in a read weight group, and then I start the writer. The writer goes through and writes everything to the channel, and then I wait for the writer to finish. I close off my channel, and then I wait for the reader to finish, because it's very possible your writer is finished writing, but is your reader finished reading? No, you got to wait for both of those things to be done, or else then you get a bad ETL that you don't write on your local computer. So we're going to come back into here, and we're going to come up, CD, async both. Great. And in this case, you notice, I don't know if you guys saw this, but there's going to be this world where like you're going to get batches of Ds and then batches of periods. It's going to be like this world because they're both going at the same time. So we're going to get a bunch of like big globs of it. But it always ends up at the very end that the writer is heavy at the first, and then the reader is heavy at the end. As it's going through things. So you're going to see very few Ds here, but at the beginning of the file, you slowly, as you progress up, see more and more Ds as it goes through it as a directory. So to finish off here, when would you do both async read and write? Anytime you have the computational power to do it at the end of the day. It's now a memory management task. How quickly do you need to get the data? By the way, most of your modern web servers or data engineering pipelines, they're using a variation of this concept, maybe just not on one local machine. at the end of the day. So like webhooks, I want to decouple the receipt of data from the processing of said data. I have a webhook, I receive it, I need to respond instantaneously to said webhook, so I just drop it in a queue. And then I say to a webhook, yeah, I'm good. And then some asynchronous reader picks it up and runs with it, sort of thing. Maybe I have a web server. I did this a lot in the past where I had a web API that needed to return like an application ID. Basically, you're doing a process that you know is going to take longer than 200 milliseconds. So you have an API, receives it, you say, great, here is your ID of your thing that I'm creating. I put a record in front of that, and then I throw it into a queue, and it's like, great, I'm gonna get to it asynchronously when I get to it, sort of thing. That is our world of eventual consistency. This is frequently seen in live data. I once built a tool where I had to read temperature data off of a vacuum chamber. So we had to read vacuum data and temperature data. And in that case, you start a live writer, like an asynchronous writer to read it in, drops it into a queue. But I don't want what that is doing to be aware of I'm storing in a database and publishing it out, sort of thing. You can use like a webhook or a WebSocket and like publish it into a database. So you have step differentiation of readers and writers there. So in this case, to summarize, let's separate the syntax of how we use a channel from when we use a channel. There's differences in that logic. And let's not get bogged down in our syntactic sugar of what a channel can and can't do. It's just an in-memory queue. It makes your life easier that way. And when we start thinking about because all of you have worked with events, if you start thinking your Go program like event-driven program, but all in memory, that's when channels start becoming really cool. Because you can get your publishers, which are your writers, your subscribers, which are your readers, and your queues, which are basically just your in-memory, your channels, which are in-memory queues. So, I think that is it. Any questions? I'm just glad I didn't, because it's snack time in 5 minutes. So, yes, hand here.
You didn't mention why your channel in the first example had to have such a huge buffer allocated to.
Such a great question. So why did I allocate 300,000 items to my buffer? Realistically, I was handing, the directory I told it to go to is my entire code directly, where I put all of my engineering files. That includes all of any JavaScript projects and node modules and things like that. So I basically, it's a buffered queue, but it's all synchronous. So the way synchronous works is you're gonna load the entire queue up, and then you're gonna tell it to stop receiving writes, and then you read from it. So you have to basically say, what is the max capacity of my node modules, which is stupid. And so that was why that was so big. Good question. I have a hand here.
Follow up on that question. Did you run into problems setting that number a little bit less than?
Oh, I started with like 100, and then I was like, I'm an idiot. And I think I even like tried right sizing it, and then I was like, what am I doing? And so I just set it to like 300,000. I just didn't, and it worked, and I didn't think about it anymore. Yes.
I live in files, and I deal with Robocopy a lot. And when you're saying something back there about reading files and moving them, could this be used in a way to move between servers and keep I/O consistent?
Such a great question. The question being, in this case, if I understand correctly, you probably have like some volumes that you have an application that is like, I'm attached to this volume reading data and then attached to this volume writing data.
Really bad throughput.
With really bad throughput. I think anytime you have a single Go application that is doing things like that, 1000% you can do things like that. Now the difficult part being is with volumes in particular is getting the application to know which one you're reading from, which one you're writing from, and all that. So like your I/O input is going to still be a struggle. But in terms of putting together the logical complexity of that problem, 100% channels are a great way of handling like, here's a thing, let me extract what I need to do versus what I'm doing with it. Does that make sense? You're separating the problem of identifying the problem. It's just like an event, like you just identify the event. So yes, I saw a hand really fast here. Is that in response to this question or is this something else? Okay, I'm gonna go back here first and then here.
Well, is there a way in Go with the channels to do more like dynamic, like buffer allocation, like unbounded?
Yes, so I used everything. In my case, I called it a buffered queue, which is a limit on how to do it. You can do unbuffered queue. However, there are two rules with that. One, you must establish your reader and your writer You must establish your reader before you write to it, basically. Because what's going to happen is you're going to start writing to it, and it's going to try and dynamically grow in size, and it's like, I'm exponentially increasing and no one's taking anything. And so it has an in-memory limit where it says, yeah, this is unbuffered up into a point that I don't let you do it. Kind of similar to the conversation about memory management earlier. So you can have it be whatever, but you must establish a reader before you write to it. Also to the point here, it is recommended to always buffer because the buffering is actually what bounds the context of how many readers you can have at a time. So if you unbuffer it, your system will just continue to establish more and more and more readers until it maxes out your memory. We're at time. I'm so sorry.
It's fine.
Do you want to take the last one? Or you want to go on a lot of snacks?
Oh, we'll end here, but I'm sure you're going to be around to answer more questions.
Yeah, absolutely.
Right?
I'll stick right here if you have more questions.
He'll be around this whole time. So thank you, Logan. Hey, just a few things before we get into snacks. Annalisa, Mariah, and Derek, if you can stand up, please. Please.
I already did.
And we got the other two back to thanks to them. Amazing job. Annalisa, if you could go to the next slide for me. Also, big thanks to our volunteers. So if you volunteered today, please stand up. We got Clark in the back, Chris, Olivia. But huge help for us too, which is awesome. And then the next one, the store is going to close at 4 o'clock. So this is probably your last break time to go and get anything from the store if you want. So definitely hit that up. But otherwise, it is snack time. So let's take a small break and we'll be back in 30 minutes.
Sorry, what were you?
Is a journey of it turned out to be that or get ghosted by IROPS. I don't know anymore. I was letting this part of the show Reddit.
So is that Brenda?
And then it's been IROPS is one. I was like, I don't know. There's an IROPS. We're gonna get a few. Their parties change.
To be honest, like they don't actually have enough for it. Or like,
I mean, I figured like when they change the booking, we have to issue a new order.
I don't say
I don't know if that's the case or not.
Well, I know Jordan wanted to postpone it for today. That would be messy.
None of this stuff was like, I don't know. So I'm like, I'm trying to.
I don't know. I don't want to show up today.
Keep going.
You think he would?
I mean, he just got back.
Docker and Docker.
I like City Man.
All right. Sweet. Well, I think we had some great networking. I saw lots of cool conversations. And now it's time for us to have our panel, which we're very excited about. We got two awesome panelists that are here. And so I'll let them introduce themselves, but I figure I'll introduce myself because I'll be moderating it, but you've heard from me all day. So I'm still Boston, but nothing changes. So here you go, Shane.
All right. Hey folks, I'm Shane Hansen. I'll try to give you like the more bragging intro as to why, I might have something interesting to say. So I've been working with Go since around 1.0. I contributed a few small changes to the language around the tar package and some debugging support. And then I've mostly been working with Go, especially with proxies, profiling, and performance analysis, pretty much for the next decade plus. So Go's been a huge part of my career, and actually the standard library has been a huge part of my career too.
Hi everyone, can you hear me? So my name's Elliot. I am actually a YouTuber by the name of Dreams of Code, if anybody watches YouTube. But I like to think of myself as a software developer first who does YouTube channels. I've been working with Go since 2018, so I've seen it evolve throughout the years. I have one of my most popular videos is on using the net/HTTP package instead of using other frameworks. So this talk is probably going to be a little bit relevant to me. So yeah.
Awesome. Yeah, so today the conversation is the standard library versus other open source tools, right? Now, we know that Go has a very extensive standard library. If you've been attending the Go meetups that meet here, what's it called? The Go user group?
Utah Gophers.
Utah Gophers. If you've been attending that, they've been doing for the past year or so, just every time they talk about one or two of the standard library packages, which is awesome. I've learned a lot attending them, presenting there. It's been great. And so we have some questions to kind of figure out why you would use one versus the other, when you would, when you wouldn't, and that's kind of what we're here to talk about today. So you talked, Shane, a little bit about how you've built in the standard library. What kind of things have you contributed to? You said tar. What other things?
Mostly the tar package and actually some of the GDB support in the early days because it was a little bit of Python code and nobody on the Go team wanted to touch that. But there's actually some Python code that is shipped with Go that's part of the GDB scripting for being able to understand Go routines and some of the data types in there.
That's awesome. So in those types of things, was it something that you saw like, hey, there's a miss in the functionality here, let me add it to the Go standard library? Or was it something you started outside and brought in later? How did that work?
Well, for those changes in particular, mostly I was really curious about the Go project. I was starting to use it at work, and I really just wanted to find an excuse to contribute. So I went looking on the issue tracker and saw, hey, this looks like something I could tackle. There have been other changes where I've like proposed it to the standard library, where that's come out of like use cases where I had at work that it didn't support it. So a good example would be I worked a lot with ingress and HTTP proxies, and as I started to work more closely with InfoSec people and doing bot detection, we needed to know the original header order for like certain bot signatures, and that was not something the Go standard library supported at that time.
Wow, that's pretty cool. All right, so Ellie, I have a question for you too. You've focused a lot on tooling and autonomy and those kinds of things. Has there ever been a time when you've been building your software where you decide to stick with the standard library and you may have to build more on top of it versus going for an open source tool? And what was kind of the wins and cons of doing that?
Yeah, I think probably the most prominent example of doing that is when it comes to testing. So I prefer to use the testing package, and my kind of ethos when it comes to using the standard library versus using open source tooling is to use the standard library as much as possible and then build on top of it. So when it comes to testing, using your own assertions rather than using an assertion framework or an assertion package, until it starts to get to things such as structs, which then you'll use kind of Testify, or as Jonathan told me, the Go CMP package in order to make testing structs easier rather than having to deal with reflection.
Wow, yeah. Reflection, I struggle with reflection every time. So, like, that kind of both of your approach is standard library first and then lean into open source when you need it. If you're starting a new project, greenfield, and you know it's going to be a web server or something, what's kind of your approach there of how you want to get started in that? There's so many web servers that Go now, but do you just lean for standard library? Why do you do that versus going for a package?
Yeah, I like to consider myself a standard library supremacist. So always using the standard library as much as possible and then adding onto it. And there's some clear benefits to doing so. But when I do try to move away from the standard library, I'll try to prefer frameworks or packages that conform or work with it. So like a really good example is when it comes to HTTP frameworks, Gin, Fiber, they're great frameworks, but they kind of diverge away from the HTTP handler interface. So I would often, in the past, prefer to use something like Gorilla Mux or Chi, which is much more, or works well when it comes to those native interfaces of the net/HTTP package.
Yeah. Did you have anything to add?
I think I've gone through something similar where for like web servers and stuff, and I write a lot of sort of proxy type stuff, which is low-level HTTP, and that's a fantastic platform to build on. And honestly, there's a lot of other libraries that maybe perform better in benchmarks but have stability issues. Like I think Fast HTTP was brought up, which I know people see the numbers and love to use it. and then you kind of crack it open and realize, oh, it doesn't support response body streaming, or its HTTP2 support isn't there, or something else that's missing. So for a lot of times, especially for those libraries like HTTP, I pretty much just stick to the standard library. But when you're doing a full-on web application and not just like a proxy server, there are a lot of missing pieces around session management, parameter parsing, that kind of stuff.
So that's great segue. So when you have to get into these further things, like say you're building into gRPC, or you want to do WebSockets or something that like where the standard library doesn't quite support that, how do you go on making a decision of which one to use, or do you start by trying to do it yourself? What's kind of your thought process there?
I'll start on this one and then pass it over. I mean, I just tend to look at a number of things, right? So I do look at performance, but I also am really trying to evaluate the stability and community aspect there. And a lot of the times, honestly, just reading through the READMEs, you can get a sense for how the community treats things like race conditions and how they balance performance and stability. So I'm really just looking for something that gives me like warm fuzzies to use in production, to be honest.
That's exactly how I do it. Warm fuzzies.
Yeah, I'm pretty similar. I think there's also some experience to draw on as well. I think initially, when it's a new problem that you haven't found yet, you will try a few different packages. And through a process of elimination, determining, hey, what works for me, what interfaces or the way that I use these packages feels right. And also kind of what the community says about each package as well. And then, just the standard GitHub things. Is the package actively maintained? Has it been deprecated or archived? That's usually a no-go, although sometimes it's the only option available. So other kind of criteria that you would apply to just generally looking for software.
I have a comment on that.
Yeah.
The only other thing I would add, I get passionate about choosing libraries, is sometimes you might have regulations based on supply chain. So you will want to look at the dependencies of your package, right? If, again, the package is built exclusively on the Go standard library, you're clean. But just you for SOC 2, you have to have a dependency tree thing. They make tools that scan it. So, if you upload it into Artifact Registry, it'll do a scan. If you upload it into JFrog, it'll do a scan, and it'll be like, yeah, great, this is clean. There's no open CVEs. Sometimes there's additional regulations based on what, organization you're in. I've never had that problem because I do warm fuzzies. But there are, if you do fintech, it comes really, I know you work it into it, so but yeah, whatever. It comes down to, the other thing you want to check is dependencies, and Go is really good about that. Generally speaking, it's not the hell that digging through NPM dependencies is, but sometimes it does matter. That's it.
Cool. Yeah, I think warm fuzzies is definitely the way to go. Kind of question for the audience: what are the number one thing you're looking for when you do have to reach for a package? How do you compare them to each other? Does anyone have any thoughts on that?
I was going to say GitHub stars, but that's not the warm fuzzies. So
Something else is just productivity. Sometimes the Go standard library, I'm the same way. Like I default to Go standard library, but then look for other stuff when it's not available or when. But the other thing is if I can just be more productive with.
Yeah, I think that's great. Yeah, developer velocity, right, and being able to develop quickly.
Yeah, I was just gonna say that. At least for me, looking at adoption of the packages as I'm exploring, I know that Go is interesting because if it's on GitHub, you can use it, right? It's not necessarily published as a package anywhere, so looking at adoption is very important. But also, I think what Elliot said about what's the word, compatibility with the standard library, something like a web framework, if it's building its own completely custom request context in its own struct that's different than something that is building wrappers on top of the primitives that already exist. I know a lot of them, Echo will use there's functions that will return the base for net HTTP request context in the exact same structure that it exists, in order to try to maintain that compatibility, whereas other ones I think fast HTTP doesn't necessarily keep that contract, and that's also, those are things that I look for.
One of the things I look for is how many other dependencies does this dependency pull in. I'd rather pull in a package that maybe only depends on one other thing than something that is going to pull in like 40 other things. I feel like it makes me more vulnerable if it's got that many dependencies.
Oh yeah, for sure. Yeah, AJ.
I like to see that it's not updated regularly. Because a package should be well focused enough that basically you only need to update it when something changes in the standard library and you need to take advantage of a better feature. If a package is, has a commit from 2 weeks ago and not another one for 6 months, that's a good sign. But if it's like a constant stream of commits, it's going to be super buggy.
Yeah, I think that makes sense. I love it when I look at a package and I only see dependabot commits go through, and you're like, okay, they're just keeping it up to date. There actually is no changes. Yeah, Jonathan.
I look for open bug reports that haven't been responded to.
Ooh, that's a good one.
That's a good one. That's a good one. And then you had one?
There's a new tool called Caps Lock developed by Google that you would run it on your package, and it will go through all your dependencies and their dependencies and output capabilities. So it would output, for example, like network capabilities or file I/O or execution or something, and then you'll be able to look and see if the dependencies that you're using have the capabilities that you would expect them to have. For example, if you have a math package, like you wouldn't expect it to have like random execution or file I/O or something, and then you would be able to compare.
That's cool. That's really cool. All right. Yeah.
I think something that's really powerful about Go and the Go ecosystem is it enables that sort of static analysis. So for a long time, they've shipped tools that allow you to like find everything that implements an interface or find all callers, which is really basic stuff for a static language, but for a dynamic language, that's much more challenging. So it's at least even a tractable problem in Go to say, yeah, what packages are going to call out to exec or os.open or that sort of thing.
Awesome. All right, I have a question, purely opinion here. I don't know if there's a right or wrong answer, but how do you feel about how kind of Go's strategy is to be very minimalistic in the standard library? Like it's batteries included, but it's also minimalist. Like if you think of there's no ORM, or we have the SQL package, but no built-in drivers to any SQL databases. Do you feel like that's the right approach, or what's your opinion on how they've done that?
I think for the most part, they've been really successful. So a lot of other languages, like say Java or Python, they had batteries included libraries when they were built, and then those rapidly became super out of date. So like the Python base HTTP server stuff was pretty much only useful for toy applications. And we also ended up with a whole bunch of like Java XML parsers being shipped for decades, even after that became like not that commonly used, and then they became rapidly out of date. Now Go's a pretty young language, but so far its networking facilities have not had that happen to them yet. And so having a more minimal standard library helps with that, but not going so far as like the C language where you have nothing. So I think so far they've struck a good balance, but we'll see in 20 years if people look at it and go, wow, HTTP, that's like COBOL. Can't believe that's still included.
I actually think there's pros and cons. And Shane's mentioned the pros here, so I'm going to mention some of the cons. So I think it's caused some fragmentation with some libraries and some issues. So lib/pq was the Postgres driver for the longest time, and now that has been not necessarily deprecated, but I don't know if deprecated is the right word, but it's now recommended to use PGX instead. So I think that's kind of a failing maybe in that model. Gorilla Mux famously got deprecated or archived, and that was, again, probably the go-to.
Unarchived it.
They did unarchive it, and then net/HTTP came and became usable.
100%.
And I think, so taking the net/HTTP as another example, because I think it's a great example of kind of everybody moved to these other HTTP frameworks, and then they decided to fix some of the core problems with the actual net/HTTP serve mucks. So I'm in two minds about it. I think it's the right approach to kind of understand some problems and then build from the community and then take what works and improve Go through that.
Yeah, I agree with that. I think as well, we were kind of seeing that happen with the JSON package right now, right? But unlike NetHTTP, where we've just been able to expand the functionality, we've had to replace the JSON package with, what are they called, JSON 2?
V2.
JSON V2. How do you feel about JSON V2?
I actually have a video about JSON V2. So I really like JSON V2. I think it brings a lot of improvements, and there's a lot of intricacies as well to it. I think the biggest improvement for me is some of the marshalling changes that are coming in. So nil structs and nil maps, not nil structs, sorry, nil slices, nil maps are now being rendered as you may expect them to be, which is either an empty array or an empty object, which I know a lot of developers will be happy about. So there are a lot of changes that are coming, again, based on kind of the usage of Go and the community response to things not working that I think is great. It's a shame that it has to come in a V2 or /V2 package, but I think it's understandable with Go's backwards compatibility.
I have no opinion on this one.
That's totally fine. That's totally fine.
Actually, I do have a question. Have you seen with slog that people have really started like moving away from the third-party tools and back to it? Because I don't know.
It's amazing.
Yeah, I really like slog. It's not as good as what I think Uber Zap was. Well, there was Logrus that got deprecated, and then Uber Zap I think was the main big one. I don't think slog is as good as Uber Zap, but again, because, and I think somebody mentioned about productivity being a really important reason to use the standard library. For me, it's also the ability to have other developers come onto that code base and know how it works without having to learn a new dependency or a new framework. They can, as long as they understand the standard library, those skills are kind of, or that code is transferable to other Go developers. And I think that's, for me, one of the benefits of using the log/slog or log/slog package.
Slog.
Yeah, I think that's a great question. So like at my company, we actually migrated to Slog recently. We were on Logrus, but we put an abstraction on top of it. And that was always a pain because everywhere we had to import our abstraction, just have standard logging. But then once Slog came out, you could just set that as the logger and then use Slog everywhere, and it just works. And I think that's a really good example of where they've made the perfect decision of migrating to something like that. So
Interop with imports, right? Like the stuff you import uses slog.
yeah.
You're not going to use your custom.
Exactly. That's the other benefit on top of it. Yeah. Cool. Well, I want to open it up to questions from the audience for our panelists that we have here. Yeah, Carson.
Sorry, I don't. Just one. I just want to like, woohoo, Go. Like we're here having a discussion about whether or not you need to import any third-party stuff. Like, can you even do this talk with another language at another languages conference? Like, the JavaScript people would just be up here like looking at you like, I can't do anything now. Like, if I can't import all the things. So, like, kudos to Go. That's so cool that we can even have a discussion about like, you actually don't need anything else.
I will say Bun seems to be taking the approach of trying to add a decent standard library into, I guess, Node or Node.js, which is kind of interesting to see. And it makes Bun kind of appealing, but yeah.
I think what's interesting with Bun 2, though, they're going further than Go. Like, they've implemented S3 libraries and specific database libraries, which is interesting, too. So we'll see how it goes. Might be. We'll see. Any other questions for the panel? Yeah. I'll bring this to you.
Yeah, so when we've talked about like HTTP libraries a few times now in this conversation, but like, so at what point, like, do you maintain your own like packages that you're using for common patterns like middleware or something else, session management, or are you, as soon as you need those things, are you reaching out to something third party? And at what point do you draw that distinction of rolling your own like supplemental package versus, you know, hopping over to a full framework that already exists instead of like reinventing a wheel, you know?
That's a great question. So middleware is definitely something that I tend to maintain my own package of, but I'm mostly the only person using my code these days. Back when I was an engineer on a team, I would favor more to use something like the Gorilla middleware package or something that is much more common that other developers will know. and then either bringing it in-house if you need to, although there are some caveats of doing that. So I think, again, it really depends. I think if there's a really good established framework that kind of everybody on your team will understand and know how to use, then bring it in, absolutely. If there's something that you don't need to bring in a full dependency for, just to quickly implement and share across your own code base, then I would prefer to do that.
Yeah, I've been thinking about this a lot lately, and I don't think there's one right answer. But I think that, so at Intuit, we pretty much default to hiring developers who understand open source libraries and can directly start contributing with just the knowledge of those libraries, which is great if you can provide all those things that like a company commonly needs, like logging, even like mesh type resiliency patterns in a way that that still allows you to just use those vanilla open source libraries. So I think of your example as service mesh as being essentially cross-language middleware. So if you have tools somewhere else to handle that, it's great. If you don't, so if there are metrics that you always need to export, other patterns that you need to enforce or followed, sometimes you do need that inner framework. And people just have to learn it because that's part of learning what's required at your company. So it's a hard balance to strike, and I don't know that there's one right answer.
Good question. Any other questions for the panelists? Yeah, Jonathan.
Each of you, a question for each of you to answer independently. What is one popular library that you hate and will never use because you prefer the standard library?
For me, it's probably fast HTTP because I think it is just not that robust, and it seems super attractive until you find out you can't do real work with it, or until it bites you at 3 a.m.
Personal friends with the maintainer, and he would agree with you.
Okay, good. I'm glad to hear that. I'm always worried that I'm going to upset someone or not know what they've done in the last 6 months, but it's been around for a long time, and it's super cool. But like, if you needed for a long time response body streaming, that just wasn't a thing.
I don't know if this is a popular one, but I've had conflict in the past. So I think it's GoMega. Is it the BDD testing? Yeah.
Go and GoMega.
Ginkgo, that's it, Ginkgo.
GoMega's the matcher.
Yeah. So Ginkgo and GoMega. I don't know how popular it is. I know it's popular from Java developers that come to Go, mainly because they like the BDD paradigm. I absolutely hate it.
The Kubernetes operator SDK leans heavy on it, but that's because it's testing asynchronous, eventually consistent processes where that flow is useful, and that's about the only place you ever use it.
Yeah. I'm not a big fan of that framework.
Awesome. Well, to kind of wrap up here from each of you, if you were speaking to a Go beginner and trying to give them advice on how to kind of get started and not getting overwhelmed with the packages we do have, even though it's not huge, what's your advice for beginners on standard library versus packages and kind of deciding what you want to do there?
So I would always advocate learn the standard library first before learning any other packages, and learn how to do what packages provide through the standard library. So a really good example is Cobra, which is a fantastic CLI framework. You can do everything that Cobra does using only the standard library, but it will take a lot of time and understanding to know how to do it. But I think that's very valuable to understand because it will teach you a lot about Go, and it will teach you also programming concepts as well, such as recursion and other things, where you can understand how to use operating system arguments and CLI flags to get the same thing, or near enough the same thing that Cobra provides. So use the standard library first, learn how something works, and then understand what problems using a third-party framework or package solves.
Yeah, I think I have a very similar answer, but I think at the end of the day, the most important thing to do first is to try and have a clear mental model of what you're building and what it's doing, right? And what you want to do. And using the standard library is the first place you look to start building out those pieces makes a lot of sense. And then you'll understand where naturally you might need to reach outside. Because otherwise, you really just end up in a state where you don't really know why what you're building works. Now, I don't think you need to carry this to an extreme. Like if you're working with databases, you don't need to re-implement the MySQL protocol yourself. But on the other hand, if you're working with databases, you actually probably do want to understand a little bit about what's going on with connection management and pooling and maybe a CGO library versus non-CGO.
Awesome. Any final comments from either of you before we wrap this up?
Go, go.
Go, go. Thank you so much. All right, we are going to... Carson's going to use the chairs. Awesome. We are going to move to Carson, who's going to... He's got like toys and stuff I think he's going to talk about. So it's going to be a good time.
All right, let me get her all set up here. That'll come in fine in a second. Just stay with me. Do these work? Hello? All right, let me log in. 1 sec. Yep, we are all set. We got it all hot and ready to go. Whoever is dissing Linux for not having graphical capabilities can... anyway, it'd be nice. All right, I'm Carson. Thank you for coming. If you're here and if you don't understand what AST is, don't worry. I'm not even going to actually define the acronym until like almost through the end of the talk. Like, you don't need to spell it. You don't need to understand it. We're going to get a ton of value. It's going to be a lot of fun. We're going to deal with fun shapes and bright colors the entire time, and it's going to be a blast. I work here at Weave, work on the developer experience team. I call myself the DevXO, the executive officer. I kind of make it so. And I want to just quickly mention Z Manzilla, who I've commissioned for the art. I have a personal pledge to pay human artists to make human art that I will put in my slides, and I will only use human-made art in my slides. So you can commission them. Go ahead and find them at their website. I'll have that link at the end as well. Really affordable and fantastic artist. Speaking of, there it is. You'll see this and variations of this that I made throughout the talk. Why? Right? I like to talk with the why. Why even learn about ASTs? Again, I won't even define it yet. I'm not going to start with the AST diagram slide that every other talk or web post will start with. I wanted to talk about like, why would I want to learn this tool? And the short answer is value. I'm gonna kind of stretch this tree metaphor a whole lot, so stay with me, right? You learn how to chop this tree down, and with the wood, the lumber that you get off that tree, you can build amazing things. It's this very simple idea that once you learn it, it's the foundation of enabling all these things you didn't think were possible before. So I'll work through this, and we'll show you some of these examples towards the end here. Let's make sure this is up and working. Okay, so do not tune out. No, we're getting to the end of the conference. Everyone's tired. Everyone wants to just go to the after party. Come find me at the after party. We'll drink together. Some kind of general idea of what we're going to go through. I will not start with the what is the AST slide. We're going to dive straight into not understanding ASTs at all and just do stuff with it, right? That's how I got there. That's how most of us start. We're like, I don't know what it's doing. I just need to get some stuff done. And Carson said this is how. Then we're going to go into fun shapes, bright colors for almost the entire middle of the talk. Because what I learned when I went to do an AST talk in Go is the AST package in Go is not interesting. It's not the hard part. The hard part is the data structure. The hard part is just understanding ASTs in general. And I have come up with a way to do that using a toy you might all recognize. And if you master that toy, you can master ASTs. Then we will dive back, once we learn our shapes and colors, we'll dive back into the actual Go AST package. And at the end, I'll do a bunch of bonus rounds where we cover like, okay, now we understand this. What does this really mean in deeper depth now that I really understand it? Whew. Okay, so first thing, want to get value. I'm going to go straight into really boring code. And I want to actually point out that there's more to your code than the thing you build from it. There is the code itself. There's all these ideas and these decisions and information encoded into your code. And wouldn't it be really nice if you could get all of that stuff out in a meaningful way? In this case, I want to get all the comments out of this code. This is meaningful data. People don't put comments in their code because they don't think it's read. What if we took all those comments out, including the things they're attached to, and auto-generated documentation? Now, there are tools to do this that are better than what I'm going to write, but I'm going to use it as an example, right? So let's do that. I could just grep, right? I could just find and replace, like find all the slashes, but that's not going to be accurate with multi-line. It's going to find slashes that aren't related to comments. I want to be code level accurate about the comments and where they're coming from. So, like I said, cut the tree down. I don't even want to be nuanced. We're going to chainsaw this tree down and get our value right away first. And batteries included, standard lib, All you have to do this in Go is import these 3 packages. I will not define them. You don't need to. Again, someone just told me this is how I do this. I'm not going to learn it. I'm just going to, we'll get there. But we're starting out with, I just want to get stuff done, right? So we import AST, parser, and token packages. And we write a little bit of code, right? The first bit of the code goes in and just gets the argument of the file we're going to parse, loads the file. It creates this thing called a token file set, which, again, I'm not going to care about right now. You don't have to worry about it. Something we have to build. Then we take the parser package, we give it our file set, our file name and content, and in this very special option that says don't just throw those comments away, keep them around because I need them. And then we get this AST file back, which is just a data structure. We'll dive into that later, but for now we're getting value first. So the core of what we're going to do to get all those comments out is just this small AST inspect function. So we will loop through, we're going to call AST inspect, we'll give it our file and a function that it's going to call on every bit of code. Again, I'm being very vague. We will come back to this. For now, just understand this function is going to take every little chunk of my code. It's going to get passed my function. I will then look and see, is this some sort of declaration, a variable, a constant, a type, or is it some sort of function declaration? Those are the only 2 things I care about in this code base. I'm going to throw everything else away. If it's either of those things, I'm going to print out the information about them from what's given to me, and then I'm going to return true, meaning keep looking for more of them, right? Don't stop. You don't have to understand this. I just want to go straight to value. So let's actually do it. Let's take that code from before and pull it over here and run it. And to nobody's surprise, it works, right? Like, this is great. This is code level accurate. It told me exactly where my declarations were. It told me what type of thing they were, and we could get more data out, but I'm keeping it really simple in this example. And no matter how crazy my code gets, this will always find all the comments for the things that I'm looking for. All right, so here's some really deeply nested code. Again, I've got comments all over the place. I'm only specifically looking for type declarations, variables, constants, functions in the code that I've written. I could get anything, but we'll just start simple. If I hit run here, then yeah, no matter how weird and deep and complex my code is, it will find all those comments and say, here are the comments that were attached. And I wrote something like impossibly silly just to show, like, this is crazy code. Don't even try to understand this, but like, there are some types being declared ridiculously deep in my code. And without me changing anything about the code that I wrote to find the comments, I can run it and I can get all of this information, right? Again, there are tools that do this for you. You do not need to write this. There's GoWestConf, which just does this, but it's a neat example. So what is a more practical use case? Again, straight to value before I dive into the how this works. So, practical use case. Unfortunately, we all have run across this in code. Code that does something that doesn't make sense, right? And it does it for reasons. Somebody's bad ideas are sticking around forever and going to bite us in the ass forever. And this is the case in this add. It takes A and B, and it always adds A and B, and then one more. And we don't know why, but it's really important, and I don't want somebody to come in here and think that's a bug and take it out and break prod, because that +1 is important for reasons that I can't control. So how do we document this, right? We document this in our documentation, and that might be in some file a million miles away from the code where I won't stop somebody from breaking this if they're looking at it during, they're changing this code. So at Weave, we decided, actually, you know what? Let's put, we wanted these architectural decision records, ADRs. Let's put those decisions in comments next to the code that is implementing those decisions. Let's put them as close as possible. The silly things we have to do, maybe they're even important things or good ideas, and we want to say, this is why we're doing it this way, and we want to put it next to the thing that's doing that. But of course, putting it here makes it hard to find and to see an overview of all those silly decisions that a code base has made. So we wanted to go ahead and take all of that and extract that out into a dedicated document. So here's some code to do that. Again, iterating a little bit on the code you saw before. We're still reading the file, giving it a new file set, parsing it. We're not going to loop over it in this case. We're actually, because if we go back, this is kind of a free-floating comment. It's not actually attached to anything you'll notice. It's not above a function or a type. So instead of doing that, we also get this just big slice of comments that are in the file, and we can just range over those, find where they're at. We use that file set to kind of locate metadata about what we're looking at. We're going to see, hey, does this start with a string ADR? And if it does, we'll print out a bunch of information about it, the file it came from, the position, and the actual comment. So really, really simple stuff. And this is more or less how I came to ASTs in general. I needed to get this, and someone told me AST is how you do that. I didn't know how AST worked. I just wrote this code. And if we run it, you'll see, here you go. So we wrote this, you redirect that to a file, you do it in your CI/CD pipeline, and you have auto documentation from your decisions from your code surfaced all the way up in your markdown just at the top of your repo. And we do this, and this is like the first thing I did at AST. It's been massively helpful to get that documentation, again, surfaced up, but sourced next to the place that's actually making the decisions. So that's where I stopped for a long time. I didn't even learn ASTs. I just used the AST package to get this value, implement the feature I wanted, and I moved on. But it got this AST thing in my head, and I couldn't get it out after that, and it just kept kind of eating at me. So again, now we get into the fun shapes, bright colors portion of the talk, where I'm going to leave Go behind. We're going to go into something else. Hopefully you've all recognized this complex puzzle device, right? And we all feel like, does anyone here feel like they've not mastered this puzzle? Okay, well, you might have a little trouble, but anyone else that feels like they can understand this and solve it can understand ASTs, because ASTs are shapes, and they're just a shape puzzle. And I'm going to do a lot of the talk now just doing that. So here are the shapes we're going to work with, right? And you might start to recognize them here. We're going to come back to this. I've got more toys. So we've got a triangle. A triangle can contain 0 to 1 circle inside of it. We've got a subtype of triangle. I made it extra complicated. I could have used a different shape, but I wanted to do a subtype for kind of analogous reasons to the Go types. So a triangle can contain up to 1 circle, or it can have a character inside of it. We can have a circle with up to 2 squares and a square with up to 3 triangles, right? And you can see that there's a loop here, because then that square can have triangles, that can have circles, it can have squares, and you can build a very, very complex shape with shapes and shapes and shapes inside of it using just these 3 or shapes, or 4 if you count the triangles separately. So let's start with the easy mode of this very, very complex puzzle system. We've got a square with 2 triangles in it. They happen to be character triangles that say hi, right? Super simple. It may not be a surprise to you that I can represent that this same way. I can say there's a square with 2 children, 2 triangles inside of it. These are, and I have a clicker, these are the same thing, right? One is just a representation of the other in what we'd call a graph diagram. And we're starting to see a very specific shape that I have not named that's part of the AST acronym, right? So everyone hopefully is grokking that these are the same thing. So let's go a little bit more complex. Here is a circle with some triangles, or sorry, with some squares and some triangles inside. Getting more complex, getting more deeply nested. We're starting to see something like this up here. Again, we can represent all of these the same way. These are the same thing, right? In one side on the left, we've got the actual physical nesting of things inside of each other, and the one on the right, we've got a diagram just with parents and their descendants, right? And you'll start to notice some important things about these kinds of diagrams is that they kind of always go in one direction. Doesn't have to be down, but down's pretty traditional. And they never really loop, right? There's no way to put a circle inside of itself physically in these puzzle systems. Like you can't literally, just like if you can come up and draw that for me, come do it. But I don't think I can actually have a circle that has a circle inside, the same thing inside itself. So we'll go a little bit harder. We're gonna make this the most complex one. We've got a circle with some squares, with some triangles, and one of those triangles happens to have another circle with squares and triangles. You can't even read it. It gets really small really quickly. If you'll see this, it gets really, really tiny, and that was the biggest I could print that base on my printer. But the diagram's actually pretty easy to read, right? It's still pretty simple. These are the same thing, and you are starting to see the T part of AST, which is tree, right? Tree meaning branches. It doesn't look quite like a tree, but if you imagine you got the root of the tree, and you got branches, and those branches have sub-branches, and those branches have sub-branches, and you can always kind of trace them back to their root or down to the children. Again, trees never grow. I'm sure they grow back into themselves technically, but stay with me. It's all unidirectional, right? This is graph theory, but it's acyclic. It always has to go one way. So everyone feeling pretty good. They understand these shapes so far. Okay, so let's go back to that inspect code from before. Remember I said you didn't need to understand what the thing was? Let's pretend instead of node here, we've written our inspect function, and node is shape, right? We're saying, okay, call this on every shape in this tree. I'm gonna give you the circle at the top, and then just tell me, okay, give me the first shape. And I get to, instead of looking for a general declaration or function declaration, I get to look for, is this a square? Is this a triangle? If not, go to the next thing, go to the children of that. Is that a square or a triangle? And I can just keep looking down and down and down. I'm only looking at one piece at a time. Something else is doing the work to kind of figure out what the different types of children at each phase is, but I don't have to know that. I'm just looking for data shapes, right? That's all that was happening before. The shapes just happen to be Go code text shapes, but they're just shapes. So let's go back to text, right? We're moving away from the raw shapes back into text, and we're gonna do that with a text markup and Go structs. So our triangle, all of our shapes are going to implement an interface that just has a depth. This isn't technically enough to accurately represent all these things, but it's enough to get the idea, right? How many layers down do you have? In other words, how many parents do you have? Do you have 0 parents, 1 parent, 2 parents? So any shape, all these shapes will have some position that they're at in that depth. Our squares can be represented with go figure square brackets when we see them in text. And struct-wise, they're just gonna implement the shape interface. They're gonna have a depth, and they're gonna have up to 3 triangles, right? So that's an array where it can have 0 to 3 triangles inside of them. Triangles are a pointer. We'll get to that in a second. But really basic struct for squares. Circles, the same thing. They are a shape, and they happen to have up to 2 pointers to squares inside. We may have none, may have 2. Triangles are going to be a subtype. Again, we're using some interfaces here to kind of add a little complexity because this is more realistic to when you're doing real AST things. All triangles are shapes, but we're going to use this little marker method to have the compiler warn us if we try to jam any old shape into a triangle. It has to be a shape that specifically says, no, I promise you I'm a subtype of this triangle shape, right? So there's a lot of ways to do this. The GoAST package doesn't use marker methods. It's just a simple way that I'm doing it for our samples. And again, another subtype of triangle circle where inside of it has a depth that has up to 1 circle inside of it, and then it is a triangle, it is a shape. So we're all good. We've got square brackets. I'll actually come to the summary here. Let me go to the character. So one more triangle. It's gonna have quotes, and again, a depth. It is a triangle, it is a shape. Here's the summary of that. Square brackets for squares, parentheses for circles, angle brackets for triangles that happen to have circles inside of them, and quotes for triangles that just have a character. Right? It's just the shapes. I'm just having to represent them instead of with actual physical shapes. We're going to represent them with characters, and things inside are just between the markers, right? Things inside a square are just between the 2 square brackets. So let's go back to our examples and convert them to text. So here's that very first example. These are all equivalent, roughly, data ideas, right? It's a square with 2 triangles inside it. Each of the triangles has 1 character. All 3 of these things are the same thing. And we can kind of understand there's a square with 2 triangles inside of it. Not that complex. Again, these are really great to represent because there's no cyclicalness in any of these. These all can't just have magic loops because text has to contain a finite number of things. Here's the medium shape. So again, same idea. We've got all of the shapes, we've got the nesting, and here's the text representation. And you're starting to see patterns and subshapes, even in the text, right? You can kind of really at a glance with some of these see that you got circles with squares inside, just looking at the text. And we're just making this up as we go, but we've written our own kind of abstract syntax tree shapes, structs and markup that can be extracted out. And here's the most complex one. Again, that's a really complex data, but especially in the text representation, it's a little bit easier to read. And this is the one I love to look at because I think it really shows like, this looks incredibly complex with all of these symbols, but it can break down into the thing on the right, right? The text here can still break down into that subtree on the right. It's just shapes inside shapes inside shapes. So we're gonna go all the way back into code examples. So our examples for code, again, we've got our square with 2 triangles inside of it. Here's the text at the top where we've got the brackets, and here's our struct representation of this. I'm really walking you slowly back into this because when we dive into the Go stuff, it's gonna be this, but with a lot more data. But hopefully this doesn't surprise anybody that this thing here is, our struct is the same thing as the data. We can take that diagram or the tree diagram or the text here and convert them all and represent them pretty accurately with this struct here, right? Where we've just got a square at a depth 0, it's got triangles, and the triangles happen to have characters. So really, really kind of simple. Don't worry, it's gonna get a lot more complex pretty quick. Here's this middle example. Again, going back to the text at the top and the struct representation, and again, you're starting to see kind of patterns emerge. You're starting to see that squares kind of look a certain way. They always have repeating patterns, you can kind of just even eye them here. The shapes repeat themselves. It's just data containing data, as deep as you need to go. And you could, again, do really complex versions of these, and we'll actually go to the most complex and you'll start to see that. So here's that same diagram from before with all the shapes. And here is the text diagram, and it gets really big. And this is where really the repeating patterns start to see, right? So if you look at the text here, the top square and the bottom square in the text are really identical. They're almost identical, except for the top one has 2 characters in each chunk instead of 1. Right? So our representation in GoStruct is really simple. Here is the first square. Here's the second square. They are almost the same thing, right? These are repeating patterns. And I'm going to come back to this. Like it's a lot of nesting. It's deeply nesting. You'll see stuff like this a lot when we work with the GoAST package. But don't be scared. It's just shapes and shapes. You can always kind of take a piece of it out in isolation and look at it. If you cut that tree off, if I go all the way back, if you cut this tree off at like one of these bottom circles, you can still analyze it entirely without knowing its parentage, right? So you can always rip pieces out and analyze them in isolation if the thing is too big on its own. So we've taken our axe to all of our trees. We've dealt with bright colors, fun shapes. We're starting to understand this idea of how you can take a lot of things, right? That was shapes and shapes, and represent them with an abstract syntax tree, which is, in case you didn't know, that's what the AST stands for. So let's take this back into Go code and get some value out of it. But before I do that, I have to go to some more toys. I have been crafty lately in my talks. I'm going to put this down, and I need the tape. So 1 second.
Just went through all your slides.
Oh! Just put something down, and it really went. Wait. Oh yeah. So, I couldn't help it. Wow. There we go. No, that's good enough. I see the one. So, in case I got my visual learners with me and you wanted to go even further and take that kind of physical toy idea from what I was showing you before, I designed and printed, and in the link we'll have at the end all my contents out there. I have the models and everything. You can go print all of these if you have they have a pretty high tolerance, so you have to have a decently good printer to like have the snaps snap in to connect the arrows. But it gives you, again, that's kind of a really fun physical way where you can walk down and say, well, I'm looking for function calls, and my function calls happen to be triangles with circles inside them, right? So you start at the top and you say, here's that. Is that a triangle circle? No. I'm going to look down to the first child. Is that a triangle circle? No. Next child. Is that? No. So I'm going to go to the sibling of that one, and then, yep, there's my function call. I found it. I can print information attached to it, like its parent, or I could follow it down to see maybe these represent the arguments being passed to that function. Again, that's all that inspect function that's doing. That's what most of your ASTs are doing, is just representing things that have things that have things that have things inside of them. I have got a bunch of things to give away, not exactly right now, but come find me. I have made this little abstract syntax toy, like carry case, that has some snaps and shapes. I don't know how I'm going to give this away. I'm just looking for somebody that is as nerdy as I am and cares enough to want it. I have extra shapes. Come find me. I couldn't help but print toys and get a little physical just because it's been fun. So, okay. I actually even have a little Go mini one if somebody wants to come find me afterward as well. Toys are done. We're going to go out of the realm of colors and shapes and start to bring this back into real Go stuff. So back to the AST package. We know that these are all the same. I've already described that this is all the same representation. I'm cutting it off at the bottom. And again, I want to really drive home that what the inspect function was doing is just walking down this tree. And in our case, that tree isn't this physical tree anymore, but it's actually just looking at children. So that inspect function, you just need to write some very light code that knows how to look at circles and know that circles have squares, and just call each of those shapes with the abstraction of that interface, right? Passing it back as an interface, which is why you have to typecast, because you have to eventually say, well, they're all shapes, but I'm looking for this shape. And is it that? Okay. So if you can understand this, we're going to move on to the Go stuff where it gets a lot more complex with the data structures, but the ideas are all exactly the same. Okay, so let's do some type examples of Go AST. Again, I'm not going to spend a ton of time diving into this for you because knowing these, this is just looking at reference docs now. Like now that you understand ASTs conceptually, you can apply it to Go's AST package, you can apply it to AST packages from all sorts of sources, and I'll kind of get to that as we get to the end of the slides. But here's some fundamentals, the ones we've been working with, right? So gendecal, remember we were looking at that in our previous, or I don't know how you say that, gendecal. This is just a shape, right? This isn't that much more complex than our triangles and our squares and our circles. They're tracking more than just depth now. They've got things like position, which is like line number and column number where things were. Or they're tracking comments that were attached to it. Remember, we were getting those comments from before. They're tracking nested things. So general declarations can have nested specs inside of them. That's all that we were looking for before. And we can get any of this out in that inspect function, right? We have access to all this data. It's there. We just were only looking for pieces of it. Functions, again, we were looking for those before in the inspect. Same thing, some really basic stuff. Functions happen to have field lists, and they have bodies, and they have types, and they have all this stuff. But again, we're just looking for a specific shape that is the shape of our function. We've got things like selectors, which if you didn't know, that's when you do a something dot something. These are specifically fun. I like to point these out because selectors, the X is another nested expression, which can be any kind of expression. So selectors, you kind of imagine this is important if you have something dot something dot something dot something. That's a selector with a selector with a selector with a selector inside. It's just a chain of selector shapes where it's a new shape containing another selector shape. I could have easily had a square with a smaller square inside of it. That's all a selector is one of those is just the same shape again. We have idents, which aren't too bad. They're, again, they're kind of like the constants of your code that aren't the quoted things. So if you look at log and print line, those are identifiers in your code calling out specific things, in this case, a package and the function in that package. And they've got things like, again, their name and their position. We got function calls. I don't need to, I'm not going to go into detail. You can go look at the AST docs on this. But again, function calls have the function, which is some kind of expression. So that expression might be a selector. Or they have args, which just is a slice of expressions. Again, just shapes inside shapes. And sometimes they're very specific subshapes, and sometimes they're very generic subshapes like this. So let's do one more practical example before I bring it home. Practical example here is we're talking about the slog package, right? And in order to migrate to slog, I have to know where I'm using the old log package to update it. Ideally, I'd love to rewrite this, and we'll talk about that in a second. But let's start with just, I want to find, in this kind of deeply nested complex code, all the times where I use one of the old log functions from the old log package, print those out so I can fix them. Again, another tool you don't need to write. There are tools that do this, but easy idea. This is the same code from the first two examples, right? We've not changed any of this. We're using the AST, the parser, the token package. We're loading up the AST file. And we're going to use inspect again. Stay with me. This is normal. This might seem, your instinct as a Go developer is like, that's so deeply nested. I hate it. I should flatten it. Don't flatten it. Like, this is canonically fine, normal, dealing with an AST. It gets way worse if you try to flatten it. I promise you it's okay. But if you squint, or maybe squinting's hard, but what we're looking at here is this first thing is a call expression, a square. Next thing is a function, a triangle. The next thing is an ident, a circle, with the first thing inside of it being one thing and the second thing inside of it being another, right? This is just very complex code to say I'm looking for a square with a triangle with a circle inside of it. And that I know is a specific call to log.println, log.printf, or print, right? And then that's pretty much all AST working with is doing is somehow dealing with traversing this graph, looking for shapes with inside shapes to find the kind of code. If you remember the nil pointer dereference stuff, right, that amazing talk, you know what they used to do all of that analysis? Like this is it. You learn this tool. That's what all of that stuff is built on, is this kind of thing. And there's actually even more use cases beyond just Go analysis. But if I run this code on the thing from before, I very quickly, with minimal, that was like almost no code, right? I can run this across my file. And by the way, this AST is super fast. You can call AST. There are ways to do it across an entire directory, not one file at a time, on your whole code base, and it's like sub-second. Like you can run it constantly, all the time. It's impossibly fast to do this analysis. We do it every single time we generate documentation across entire giant code bases, and it's almost instant. So this is where I can go back and fix all those and run this command until I see no more outputs. How did I get those shapes though, right? Let me hop back one more. How did I get, oh, I'm just hiding it. how did I get like this specific series of shapes? It's like, how do I even know that that's what I'm looking for? And there's a couple ways to do that. The one I actually highly, highly recommend is astexplorer.net. It's a really, really great website where you can go to astexplorer.net. I'll actually pull it up now. Try not to go through all my slides this time. Right? And this is the Go code from 4, and it's great because if you click in on any part of this, it auto drops in. On the right is the big, giant, hugely deeply nested structs within structs within structs that is this code base on the left. And I can go in and click on and highlight over specific things to say, yeah, oh yeah, I'm looking for a selector with an ident inside of it, and that would be my printf. Or if I highlight this, I'm looking for a call expression. Like you can take this, you can extract bits of it out, and you can use this to figure out, put the code in and figure out what you're looking for. And it's way easier. If you don't have these tools, I use sanity.io to like pretty print entire structs. And the structs are like really great pretty printed, just looks like giant JSON. And you just find the shapes you're looking for and code them up. So the other thing I'll point out, again, I talked about value. Look at how many languages have ASTs. You can represent a ton of things with ASTs. Not everything. We were talking about certain scripting languages and things just are not static enough that can even have really an AST or an effective one. But there's tons of stuff in here. And we used ASTs from other languages to some great effect. And I'm going to get to that before I run out of time.
Of time.
No, that says 4:28.
Okay, you've got 2 minutes.
Okay, I got 2 minutes. I need 2 minutes. Don't take my 2 minutes. All right, next thing is AST package from Go is amazing. It's not great for rewriting. You can load it, you can slightly tweak it, and you can definitely write it back out. GoFump just loads and writes. But if you want to really change it, like find all your calls and rewrite them or move function calls around, use the DST package, unrelated to Go, but it interops with the AST package, supports auto imports updates, it tracks like the source path of package imports where things came from, and does rewrites better. So just know DST exists. If you're going to do some automated rewrites, just know about that, it'll save you time. Finally, some practical use cases. Filter strings, we recently implemented, are working on implementing standardized filtering across the Weave APIs, where we take these AIP-compatible filter strings, parse them into struct fields or SQL statements, and there's a library that can just turn these into an AST. And as soon as I saw the AST, I was suddenly instantly empowered, because now I know how to find out all of the information about that filter string in a really sound and understandable way. Something really amazing we've been working on is a VS Code notebook extension, where you define API calls to the Weave API surface, the internal API surface, as a developer here at Weave, and you hit play and it executes it and shows you the results. And it saves this all as markdown files. I could go on for an entire hour on this. But we wanted to hover over, like namespace ID and tell the person the comments from the protobuf that defined that field. And so I need to find out if you're in a code block, what code block, and if you're in JSON code block, what path you're hovering over. There is a markdown AST where you can find out if I have a position, if I hover over a position on this file, I can find out using that AST in the position I'm hovering over, what block I'm in. Then I can sub-parse that with a JSON AST to find out what package path I'm in. And it actually enabled this feature where inside this notebook, inside JSON, inside Markdown, you could hover over a field and we could figure out where you were because we understood ASTs existed and can give you the documentation from the API for this call, which is really, really cool. I didn't think it was possible. I thought it was a pipe dream. That is it. I am out of time. Hopefully you're starting to see the value. Again, this is a tool. You may not use it, but like you'll go and start to see these patterns and these shapes within shapes. And hopefully you get just a bunch of value out of it. Again, even outside Go, this is something you'll see in a lot of languages. Go's just an amazing language because it's so accessible to look into the internal types, and these are shipped with the language. Thank you.
Thank you, Carson. Awesome. We're just going to slide into our last talk here, which is Jonathan talking about how we're already all running his code in production, which is pretty cool. And then I unplug this for you?
Yeah, go ahead.
All right, here you go.
And just a reminder, after this talk, we'll have the raffle and after party, so don't forget about the after party.
Yeah, I'll get all my toys off the stage.
Definitely stay for the raffle after this.
Yes, power is useful. All right. We've had a lot of technical talks.
That's the point.
Yeah. I'm going to be a little bit easier on you. I think that's good at the end of the day. You don't have to wade into technical stuff too much. But I do want to challenge you anyway. Who here is a Go contributor? Who's contributed to the library? We know you have. Just two of you? All right. Well, me too.
Welcome to Utah.
Yeah. Who here would like to? Yeah, that's what I want to see. Who's afraid of contributing? This talk is for those of you who just raised your hand. My goal with this talk is to lower the inhibition level, make it look a little more accessible. Hopefully you'll see by the end of this that it's not as scary as you might think. My goals for this talk are to tell you who I am, describe a little bit about the process of becoming a Go contributor and through the story of how I became one, and hopefully encourage you to do the same thing. Some non-goals are to be exhaustive. I'm not going to go into every detail, and I'm not going to talk about a lot of code. There's a little bit of code here, but you don't have to understand it. If you want to, that's fine, but it's not important. This is my least favorite slide of this presentation because this is where I talk about myself and try to convince you that you should hire me or follow me on YouTube or whatever. I am a Go developer. I maintain a couple open source packages. Probably none that you've used. I wrote and maintain Kivik, which is a SDK or client library for CouchDB. I'm also a co-maintainer of Gopher.js, and I've contributed to a large number of other projects. I'm a fractional Gopher available for hire. If you would like to run more of my code in your production, follow the link. Also mentor people with Go and career advice. Was the Amsterdam I'm an ex-co-organizer of the Amsterdam Go meetup group back when I lived there. And does anybody here listen to Cup of Go?
I do.
Yeah, all right. I'm the co-host of Cup of Go. Has anybody seen my YouTube channel, Boldly Go? Got a few hands there too. Cool. Stickers were out. I think there's still some if you haven't picked them up. If you want stickers for either of those, go pick them out. Just for full disclosure, Brewster, the little brown gopher, was AI generated. I know. The Vulcan gopher, though, was human created. All right, let's talk about contributing to Go. Long, long ago, I already mentioned this, that my library, my Kivik library, the CouchDB driver, I got a request, not a pull request, just a feature request. I imagine more people here are familiar with MongoDB than CouchDB. Anybody here, who here has used Mongo or CouchDB, either one? Pretty much everybody's touched it a little bit. So in both of these libraries, both of these packages, you often use regular expressions to search for things, right? The feature request was that when they were passing a regular expression to a particular function, it wasn't being converted into JSON as they were hoping it to be, because Mongo uses BSON, but it's similar to JSON in theory, right? So the request was, can you make Kivik convert regular expressions to JSON for me so that I don't have to do this myself? I thought that's a really great idea, but I don't think that's my job. I feel like that should be part of the regular expression library, right? So here's just a simple example of the problem. This would print this output. Instead of printing the regular expression foo question, it prints empty braces. Not very useful. And this is what they wanted. So I created a proposal on the Go issue tracker. And there's links here. If you want to go read everything that happened, you can go read it later on. But I basically said, can we make a regular expression library that support? I actually asked for text marshaller rather than JSON marshaller because JSON uses the text marshaller. That detail doesn't really matter, but it would solve the problem, right? By making regular expressions convert to JSON properly, JSON strings. So after my proposal, we got some discussion. MV Dan, Daniel Marti, said this would also be nice for, and I don't even know what the issue was or if I talk about it here, but he said this would be nice to help solve this other problem. Um, So anyway, the point here is there was some discussion, some back and forth, different people were involved. If you look at the dates here, this is back in 2021. I don't remember the date I proposed this thing. May 13. So that was the next day, about a week later. And then in June, so a month later, Russ Cox says this is likely to be declined. Oh, I thought I liked Russ. It was so sad. But then Roger Pepe piped up. He said, I think it would be fine if we did the equivalent, whatever. He basically defended my proposal. So then Russ decided he wanted me to like him again. And I don't know. I don't need to read all these comments to you. The point here is there was back and forth. And I was sad because we weren't going to do it. And then I was happy again. Based on the discussion above, this proposal seems to be a likely accept. Fingers crossed. I hope it makes it. Has anybody here followed an issue like this and seen how it goes in the issue tracker? It takes months. This case is a month and a half from the time it started. It's not that long yet. We're getting there. And then finally on July 28th, so it sat there in likely accept for a little over a month. No change in consensus. It was accepted. So problem solved, right? I'm a Go contributor. No. But I was really happy because my proposal, somebody validated me, and I felt those warm fuzzies that I look for. So, but who does it? Now it's been accepted. What happens next, right? Oh, Russ says he's going to do it. I'm going to do the implementation. Great. I don't have to do it. I can just let Russ fix my problems, and I get to go home happy. That was July 28, 2021. On January 3rd, 2022, I said I could do this. There's been no updates, just crickets after that point. And then in April, months later, Josiah asks Russ, are you still going to do this? So anyway, I decided to try it. Let's take a little detour, though, and talk about the Go proposal process. I'm not going to go through all the details, of course. My point here isn't to teach you how to contribute to Go, but to make you less intimidated about it. So there is a contribution guide, which you are encouraged to read if you want to do this. It's a little bit scary. The scariest part, though, is learning Garrett. Yes. Who here has played with or tried to use Garrett? A few of you, yeah. Anybody who contributed probably have, although you can technically contribute through GitHub. You're encouraged to use Garrett. What is Garrett? It looks like GitHub if it had been written in 1991 in PHP. It's actually a very powerful tool. It's a little bit too powerful, maybe for mere mortals. But it's not that scary. The parts you need to know are well documented. Just follow the instructions and you can do it. Basically, you check out, first of all, you have to create an account, a Google account. If you're anti-corporate, sorry. Then you need to download your code just like you do a Git clone on GitHub. Follow some procedures. It's not complicated. Don't be intimidated. Just follow the instructions. You'll get there. So I'd volunteered to do the work that Russ was going to do for me and never got around to. 11 months later, I finally wrote the code. This is my contribution to the standard library. Yes, thank you. Thank you. It doesn't do much. It calls an existing string function. It just wraps the string function for marshal text, and for unmarshal, it wraps the compile function. I wrote two little function wrappers. That's all I did. I did write some tests. I don't think they're on the slideshow here, but I did write some tests too. And then I got to wait for review. So here's Garrett. This is what it looks like. I told you it looked like a 1991 PHP app. Then Ian Taylor, said I needed to make some changes. He hated my code. He hated me. You'll need to add a new file to GoRoot API next. What is that?
Exactly.
Similar to the existing files, make sure that Go test, Go build passes with your changes. What? Okay, I thought that the test passed. I don't know what I did wrong, but I felt like a moron. So I made the change. I'm not going to walk through the change. It was pretty straightforward. Once I read the docs, it wasn't a big deal. I made a change, and then he nitpicks my commit message.
That sounds right.
Yeah.
My experience working with Go team members.
Yeah. So I had to lowercase a word. That's worth a comment, right? That's worth his time and my time. Yeah. I did it. And the last paragraph doesn't add any useful information. Omit it. Okay, I deleted a paragraph. All right. There was also some nits about how tests were done. We don't want a failure on one regex to stop all the rest. So use t.error instead of t.fatal. That's a good call, actually. That's probably worth doing. My Go doc was wrong too. I put parens in at the end of my function thing. re.string open close paren, and I wasn't supposed to do that, but I fixed it. And then it got merged. So look at the date here, March 27, 2023. That's a little over 2 years after it was originally proposed. To write 10 lines of code.
This sounds very encouraging. Use AI.
So
2.1.
So my code was released with Go 1.21, so it's been out for a little while now. You've already been running my code in production for a while. And that's the release notes. My name didn't even make it into the release notes. Just barely a link even mentioning that it happened, but that's okay. That's my story. That's my story. I want to leave though with some comments. Somebody said it's not very encouraging. Let me talk about things you don't need to do or have or be to contribute to the Go library. You don't need mad hacking skills. You don't need to be a super genius. If I can write those 10 lines of code, anybody can write those 10 lines of code. You don't need deep Go knowledge. I imagine anybody in this room with an hour of research, if you had zero Go knowledge ahead of time, with an hour of research, you could have written that code. And I'm sure there's 1,000 other contributions you can make that require the same amount of Go knowledge or less. The key is finding something useful to do that people want. It's not about being the best Go developer or anything like that. It does require patience, though. We talked earlier today about how the Go team is very conservative in accepting things in the standard library and so on and so forth. That's part of the reason that this took so long. They don't want to just accept every proposal. Everybody might have a great idea about something they could add, but we need a process to not have too much churn so we can trust the standard library to be productive and safe and so on. So patience is a virtue in this process. And humility helps. It felt harsh when I got those criticisms from Ian and from Russ about maybe closing the proposal and so on. But I haven't spoken directly to Russ, but I've spoken to Ian. He's a really nice guy. I know that he didn't mean anything, certainly didn't mean anything personal by what he said. But still, you can take it personally, especially when it's a project that kind of feels intimidating. So approach it with a little bit of humility and be willing to learn new things about whether or not to capitalize the M in make or how to write your Go doc or whatever. Is anybody here now less afraid of becoming a Go developer, or did I make it worse? I saw a couple of hands go up timidly here. All right. One of my goals with my social media stuff, my podcast, my YouTube channel, is to make Go less scary, whether it's contributing to the library or not. If that's interesting to you, you can follow me. boldlygo.tech is my website. If you go to /daily, you can sign up for my daily mailing list. I don't actually write daily these days, but up to 5 times a week when I have the time. Listen to the Cup of Go podcast, or soon I'll be uploading to YouTube again. I did an international move last year, so I haven't gotten back into that, but I will soon. So if you scan that QR code, it will take you to the slideshow and links to stuff if you want that. I'm sure we'll share it on the Slack channel too. Are there any questions? Yes.
Did you get to close your original issue?
Yeah, it was closed automatically by the Gopher bot, or the GoBot, or whatever, yeah, but it's closed now. Oh, you mean the one on my project? Yes, that's closed too, yes, yes. Any other questions? Yes.
How do you handle like the feeling of like responsibility of the code going to production? You know, what if it caused like a bug or something? Do you feel bad, or you know, how do you manage that kind of like scariness?
That's a good question. The question is, how do I handle the responsibility of my code going into production? In this particular case, I wasn't concerned. It's such a very simple piece of code. I didn't write any logic, as I mentioned. I just wrapping two other functions already existed. But that's a real question. You know, it's a real concern that comes up all the time. Maybe not in this example, but I write tests. I do the best I can, and I know that I will fail anyway. And so I think this gets back more to the philosophy of how do you write quality software, and good observability tools, good logging, good stable release processes, so that when you find a problem, you can find it quickly and you can release the fix quickly. That's far more important than code reviews or whatever. You know, code reviews are good, but at the end of the day, bugs will get into production. There's no way to avoid it. So prepare yourself to respond as quickly as you can. Yeah.
Have you ever ran a git blame on it to see if it's still
So actually, shortly after it was merged, they discovered an issue. It wasn't a big issue, and Rust just fixed it. I don't remember what it was. It might have just been documentation. But yeah, I don't know. Anyone else? Yeah.
When would you try and contribute to the standard library versus just like making your own open source?
Is the question what, like for a new person who's approaching it? Okay. If I understand, the question is what could a new person contribute to the standard library as opposed to building their own library?
Or like, why try and
contribute? Oh, why try? If you want to. If you want to build your own library, of course, that's great. I do that too. But you know, in this case, you know, it was a feature that arguably belonged in the standard library. And so, you know, I could have solved it in my own library, but then I would only solve it for me, and I wouldn't solve it for everybody else who might care. So I think both are great. Yeah. Yes.
With the open issue on your own library, was there a period of time where you did, you know, solve it manually while you waited for this proposal to go through and everything else, or did you just leave that issue open for 2+ years? Just curious.
It's a good question. I left it open for 2 years, and in this case, the reason is because it wasn't very hard to work around. There's another case, actually. I'm working on another contribution to the standard library now. It's actually a bug fix in the SQL driver. That I wrote a library. It's basically a proxy driver for SQL to do extra logging for debugging, and it uncovered a bug. I worked around that in my library because there's no, like, in this case, the user could just send a string instead of sending a regular expression object, and it works. So, you know, maybe it's a little bit annoying, but it was not very annoying. In this case with the SQL thing, there's no way to work around it except to work around it in my library. So there I do work around it, and then once it's merged to the standard library, hopefully it'll be included to 1.26, then I can remove it from my library in that case. So, anything else? Yeah?
We're gonna get a tie like that.
Wonderful question. I had this one made. So Russ Cox and Rob Pike, maybe? I don't remember who. A couple of them. They published the patterns in multiple colors. So I just got that pattern and sent it to Zazzle for I think I spent $23 on this tie. There's time for questions because I went quickly, but if there aren't any more, I won't keep you here. I think we'll give away some things next. Oh, there's over here. Yeah.
So, in your opinion, what should be the good solution for the lack of reviewers, or kind of like very cool?
What's a solution for the lack of reviewers? Is that the question? Because
kind of like code contributors.
Say it again.
Of code contributors.
Oh, lack of contributors.
Lack of reviewers rather.
Of contributors, yeah, because when you write a contribution, it sits there sometimes for a while. Is that what you're talking about? I asked Ian this question on the podcast a few months ago. I didn't ask him that direct question. I said, what can we do to encourage more contributions from people and get them through quickly? And his answer didn't satisfy me because it was a good answer, but it was follow the procedure. Basically, don't do what I did and write bad comments. So I don't have a good answer to that. I'm frustrated, I have to say, sometimes in both the process of the proposals. I've provided a few proposals that have gotten a little attention but never advanced, and I don't want to nag the Go team. I know that they're busy people, and they're doing a lot of good work. And then when it comes to writing code, I wrote this SQL bug fix I wrote a year ago, and it's been sitting there and hasn't gotten much attention. I think it's finally gotten attention again, and I'm ready to. I just need to do one last change to get it merged. I don't know the answer. I guess the one thing I found, if you've contributed something or are trying to contribute something and haven't got the attention you need, the Gophers Slack has a contribution, something like that, channel where you can ask for review on your thing and you'll get attention that way. That's how I got my SQL fix. That's how I got it some attention again. So, yeah. Anything else? We done?
Yeah.
Thank you, Jonathan. What some awesome talks today. It's been so fantastic to be here with you all, and we definitely will do it again. But before we talk about that, we have some raffles to do, and I hear Derek is the one that is leading this. So.
I'm in charge of handing things out.
All right, so for the first thing we're gonna give away is a couple Gopher plushies that we had made.
They're backpackers because we like mountains and hiking. And the backpacker.
All right, and the first one's gonna go to Hamza. All right. And the second one is going to Donnie Skousen.
This next? Do we do the Lego next? Okay, Lego.
All right, we got a F1 Lego set.
Aaron. We like Legos.
And that is going to Richard Bird.
He did raise his hand in the back saying he liked Legos. Should we do the mini PC?
Which one?
B-Link mini PC.
Yeah, B-Link Mini PC. What are the specs on it?
Oh, I don't know. I got it off Amazon. 16 gigabytes of memory, 500 gigabytes of storage, Intel N50 processor. 60. I have one of these at home. It's the same. It's like a Pi, guys, but better. It's not. I don't think it's an ARM processor. I think it's AMD. There's your difference.
And that one is Justin Carmody.
Justin Carmody?
Oh.
Have to be here to win.
Tell him later.
Logan Brewer.
Okay, should we do the keyboard or the Polaroid camera next? Keyboard? Okay, this is a Newfie Air 75. I have one. It's amazing. Fits right on top of a Mac laptop if you hate Mac keyboards. If not, it's just a great keyboard.
All right, Derek Laird. Wonderful. Max Hamilton.
Oh, let's go!
And then we have a lovely Polaroid camera
it to take pictures of the party.
Can use it to take pictures at the after party.
Yeah.
They won't go on social media. They only print.
Chris Bulger.
Headphones?
Bose headphones. David 10. No David?
I'm David.
One. Oh.
I mean,
All right, we're moving on.
Sorry, Dave.
Barrick Berenson.
Eric's not here either.
Oh, two misses.
Ryan Ball.
Okay, last one.
All right, the last one, the best one, a Nintendo Switch 2 with Mario Kart World.
It's the Costco special with the year Nintendo Online.
Dang, okay.
Jan Peterson.
He has some closing thoughts, and then
You should tell the whole thing.
my wife wanted one.
Party out there, there's a bartender, they can hang out or leave.
We do have a small after party. There's a bartender. It's all included. You don't have to pay nothing. Feel free to help yourselves, hang out, talk amongst yourselves.
Alcoholic and non-alcoholic
yes.
options. And you
Take
can
all kinds here.
We love everybody. We're all inclusive. Stay and hang out as long as you want. Essentially, what we're getting at. Derek leaves at 9, and that's when everybody has to leave.
Dang.
Thanks everyone for coming. We hope to
so much.
see you next year.